Oh, we're live. I didn't realize I hit the button yet. So, I'm a little late today. I was a little bit, I was procrastinating today. Um, but there's been like so much interesting stuff that's gone on in the past week that I want to talk about stuff. So, even though I'm procrastinating, we're starting like an hour or two later than I wanted to. And there's no good excuse. I was just watching TV. Needed to take a shower. I hadn't taken a shower yet. Time to take a shower. Okay. Now I can stream. Um, but there's just been so much good stuff that, and also I wanted to say that I was just wrong last week. Last week, my whole thing when I started out, I said that, okay, I'm going to try just one project. We're going to do one project. That project is going to take up the whole stream, and like I can focus in, and I'm not going to try and distract myself with like news articles or news items or things that like that take up any time while that thing is going. But the truth is that just like it didn't work out very well. First of all, like there were just long periods where I just kind of had to waste time while the agent worked. And then the other thing was that I noticed that afterwards, when I use an agent to sort of cut up the stream and turn it into little clips to post on YouTube, because I know nobody's going to sit here for a 3 to 6 hour stream. And it was so that process is interesting because the way I do it is first I have an agent that cuts up the 6 hour or whatever stream into 3 hours, just cuts out all the little in between things, cuts out the ands, the ums, the ors, the buts, all those things like that. And then after that, I have an agent that sort of comes up with little narrative bits and says, okay, what things would make sense as smaller clips, whether it's like 20 minutes or 5 minutes or smaller clips that kind of like are self-contained. And it just struggled so hard with that. First of all, the first time it created a 5-minute clip for the entire thing, for the entire 6 hour stream. And then afterwards I was like, no, make it longer. Make sure you've got enough stuff for, whatever. And then it tried to create an hour-long clip that was just like basically the whole stream, but even more condensed. And so, and then when I said, okay, no, make them 20 minutes, 5 to 20 minutes. I created one clip that was 5 minutes and one clip that was 20 minutes, and it was just bad. It was just bad. And the whole reason why it was bad is because there was no narrative sort of cutting points. There's no narrative stopping points. And also it was like trying to come up with ways to create like a meta narrative. So there were a bunch of different points at which I talked in a meta way like this about the stream. And it tried to cut those together and create like a clip where I was talking about how it's so much better to do one project at a time. And it's like, I did have that as an experiment. I did that as a test last week. But I would not say that the test was successful. So even by the end of the stream, like towards the end of the stream, I was saying stuff like, I don't know, I don't think so. It just didn't work out. But this is why I'm doing this. I'm learning sort of what works and what doesn't. I'm getting better at speaking about things. Like that's the main point of this, is to be able to like extemporaneously. Let me quick like look up, what does extemporaneously? It looks like I looked it up before, but let's look it up again. Extemporaneously means doing or saying something without any plan or preparation. Yeah, well, okay, there's a little plan because I've got some stuff. This is like some stuff that I've pre-prepared a little bit. But yeah, that's what I'm doing differently this time. Is this time I do want to actually I have like a prepared thing where I'm going to go through stuff. I'm just going to go through some stuff that I think is interesting. And so I'm going to try and go through more different things today and not try and like dig into any one thing too much. And we'll just see. This is an ongoing experiment with streaming and video and YouTube and speaking and all of that. So we'll just see how it goes. And so far, so good. I mean, like, even if it's a total flop of a week, I don't care that much. I don't really care that much if it's a flop of a week. Because I just go on next week and record something else, or don't. Although so far I've been pretty consistent. I've done one a week, even though sometimes I have to shift the days around of the week. But actually, let's start by talking about what happened last stream. So last stream, I set out to like have Qwen optimizing itself. So the idea was that like I had one Qwen running on a desktop server somewhere, and then I have a Qwen running on this computer here. And I used the desktop one to basically start a agent that would optimize this one here. So we can't have it all running on the same machine, because if we had it all running on the same machine, like it's going to conflict with itself. And as it chooses different serving arrangements, like it was going to affect the agent's work itself. So, but I also wanted it to be all Qwen 3.8 27B. I didn't want to use Codex or Claude or Gemini or anything. I didn't want to use Grok. I wanted to just use Qwen 3.8 to do an optimization pass on Qwen 3.8 and just see how fast I could get it running on this Strix Halo machine. And so by the end of, so what happened was I started it and I just said like, I'm going to let this go and see how long it goes. And I have to say it was really, really, really cool, because it went and so even though I had some concessions on the way that my desktop Qwen 3.8 27B was set up, I didn't have the full context window of 200 and something thousand tokens. I only had 100,000 token context window, and that context window was served from a quantized KV cache, of an 8-bit quantized KV cache. And so then the question was like, is this going to be able to stay on task and on track? And I did use the Pi coding agent with the goal extension. There's like a goal extension. So there's a little bit of scaffolding in there that's just helping it stay on track and keep going. But like small models in the past have had all of those advantages, and I've been able to put it in that harness, and after one or two sort of like tries, it fails. And specifically where I think it fails often is using when it goes up to the compaction step, where it's like, okay, I've hit the end of my context window. I still have more work to do, so I need to compact everything down and then keep going. And that's where like Muse Glimmer, it did okay, but after like 2 or 3 of those, it just kind of lost the plot. But this was the first time I've ever seen one that just stayed on track. Every time it compacted, it would realign itself. It would maybe reread a few files again and then stay on track and keep going. And it kept on trying different configurations and different configurations. And it was doing things, not just like tweaking parameters. It did a lot of things. So, okay, I'll kind of skip to a little bit more. So this is it created this doc so it kept track of all of its progress in a bunch of different files. I told it to keep track in one file. It didn't quite follow that. It scattered files throughout wherever. But I did tell it to create a report at the end, a markdown file with a report. And this is that markdown file. This is that report. And in fact, what I can do is actually go to the report itself, so you can see like the markdown of it. This was the markdown of it. And just so you can see that it's like, I'm showing it in this nicer way because I've got neural column and it's a nice little renderer. But yeah, so it kept track of all of its stuff. It kept on track. It went through compactions, and even after compactions, it realigned itself and kept going forward. But what I was really impressed with was, so these are some of the trials. This is like saying, okay, it reran it. These are the mean, median, and P95, as well as, I thought was really cool touch, is that it added a time to first token. And so this was trying different things. These are the quants that it was trying. Like it tried different quants like Q5, Q8. Like there's a possibility that due to memory alignment or due to the way that like the architecture is set up, that like one of these higher quants could have been better. It could have been faster or better. It's extremely unlikely, but it was worth a shot for it. But most of what it did was trying different numbers of multi-token prediction awareness. So like the one that ended up winning was it used multi-token prediction to predict 4 at a time. And there is a trade-off there. Like some of these lower ones where it predicts 2 at a time, or tries to predict 5 at a time, or tries to predict 6 at a time, or just 1 at a time. like there are different trade-offs, because when you get it, when one of those if like one of 4 is wrong, it has to go and do all the rest manually from that point forward for that batch. So like if you set it for a really high number and then it's not correctly doing that, that can actually hurt your performance rather than improve it. But what was really cool was that I had given it a little bit of information, and I said, like, there's this D-Spark and there's this D-Flash stuff. So go look that up too, and this was in the original conception of this like plan here. Was I said, okay, like go look up D-Spark, go look up D-Flash, and it turned out that for my local system, this AMD system that I'm running on, there weren't D-Flash and D-Spark stuff that was all ready to go. So it actually ended up, and also it realized on its own that the D-Flash stuff from the previous generation, the Qwen 3.6 line, was actually somewhat compatible with this new line. And so it patched the old D-Flash code to get it working with the newest versions of everything. So it was literally downloading. The other thing was, for VLLM, let's see if I can find it. Yeah, for VLLM does not out of the box support my graphics card, but it found online these forks of VLLM that do support it. And it basically found versions of that could then support D-Spark and D-Flash. And here was what it found was, it was really bad. It was like, wait a minute. Yeah. We're talking 6 tokens a second, 9 tokens a second, and D-Spark 2, 4 to 5 tokens a second, up to 10 tokens a second. And VLLM, like these VLLMs, it was trying an FP8 version. But yeah, so it just, and it created this whole document at the end where it kind of, I'm going to say, in a very deep way, it documented everything that it had done, and it gave good reasoning as to why this is the winner. In fact, it tried like a couple of different times too. If you look up here, it didn't trust its first run, so it reran it, and to make sure that it was still the top, and it was. And so this is actually changed. This affects how I serve this now. Like, I actually was hosting it with a number of 2 before. That was what I was like in a very early test. I kind of did a 2, a 3, a 4, and I found 2 was the best with just a quick early test. But this did a very rigorous test based on my real world scenarios, which is like kind of the benchmark that I picked out last time, or I created last time. And 4 was the best. So 4 is the one I'm going with now, and it's been great. But yeah, like what was so cool to see was it didn't just an SGLang. It even went and it tried to get SGLang working, and it just could not get it to work. But it was doing things like it was patching the 3.6 Qwen D-Spark weights so that it would fit into the newest harnesses and stuff. It was just so cool to see that a local model was doing so much sort of like extracurricular, or like it was doing all of this stuff that was meant to keep it on task and get to the goal and stay on target, right? But it required sort of like broadening and doing other things, like the research to figure out how to get VLLM working, or the research to figure out how to patch. I can't remember if it patched D-Spark or D-Flash, but it patched one of the 2. At the idea of like going and trying to find an SGLang that would work. It was dealing with things like out of memory errors and trying to patch and figure out how to do those. And it eventually did. It eventually got to a VLLM that inferenced and got to the end. And so, I don't know. And it even like has caveats. I will say this was kind of my takeaway from the last stream, by the way, is that time to first token is just brutal. It is just brutal. Like the prefill. I think maybe one day what I want to do is like fork Llama CPP and just see if I can like do some crazy technique to improve the prefill time, because it just feels like to me that this is the thing that lags. This is the thing that lags. It's all of the context that you want to just inject and get the KV cache out of it. And then the inference is reasonably fast. The inference is fine. But it's like if you're waiting 5 minutes until you get to the part where you're doing your inference, and the inference can be as fast as you want, but if you're sitting there waiting for it to start, it kind of sucks. So anyway, I think like in general, my takeaway from this experiment was that Qwen 3.8 27B is formidable. It can stay on task. It also is a good indication of its compaction skills. It's also a good indication of its goal following abilities and its instruction following. And it's also a good sort of investigation into its like document writing capabilities, because at the end it had to take all of this stuff that it scattered all throughout and write this document in Markdown and kind of like stand behind it. And so overall, I'm really impressed with, I'm still just impressed with Qwen 3.8 27B. I have to say, so my maximum number here was 24 tokens a second or so. But I've been seeing, and so like, and this is, I've talked about this before. This is that AMD Unified Architecture 395 plus Strix Halo, whatever. And it's reasonably similar. If you look at specs from like what this supports and what other things support, it's reasonably well matched with the DGX Spark in terms of like its unified memory architecture, its memory bandwidth, its like number of compute units on the chip. Like the actual chip itself is reasonably, like has a certain speed, and all of those things are pretty well matched with the DGX Spark. But there's been so much more community support and vendor support, frankly, for the DGX Spark that like they're seeing incredibly good performance on their machines right now. Like they've had an entire community doing this, and as well as like the vendor, NVIDIA, is really pushing forward to try and optimize their DGX Spark stuff. So you're seeing things like 50 to 100 tokens a second on the DGX Sparks of the world, whereas I'm kind of stuck here in the 24, 25 tokens a second, which is fine. Like it's fine. But it just goes to show you the power of like, okay, if the vendor is on top of things and if the community is really invested and on top of things, you can get a lot out of there. You can go far. So yeah, I have to say that like I've been watching in jealousy. And the other thing, by the way, so the the DGX Spark. Am I right about that? DGX Spark. Yeah, NVIDIA DGX Spark. That's one thing. But the other thing is all the Macs out there that are big enough to support this. And a lot of energy has gone into making Mac inference fast as well. So like seeing both of the, so I did my little experiment and I ended up getting it from, look, like what, like 20? I think like I was running it, where's 2? 2. So I was running, this is what I was running, 22. And then after all of that, I got it up to 24 to 40, right? But then if you look at what's happening in Mac and on DGX Spark, they started out similar and now they're up at like 70 to 100. So that's a little bit of a bummer. It just, yeah, again, it goes to show the power of community, the power of vendor support, and many eyes. And also just humans. Humans are still so good at this. You know, a model that's looking for, you know, hyperparameters tweaks, even though it's doing weird things like patching deflash in to make it work, or doing things like n-gram optimizations. Which my understanding with this n-gram stuff is that, like, I actually didn't see that it had tried this, but I was reading about it, and I'm pretty sure what this does is it like looks for things in the past of the context and tries them and sees, like, uses past stuff as speculative decoding. So where it makes a lot of sense is like if you're in the middle of generating an object and then you like close a string and then you see a comma, it's like, oh, well, there's probably like a new line and then a bunch of spaces and then an opening of a string, right? Like when you get into JSON output, like there's a bunch of these n-grams that you can really easily predict just based on past behavior. And so, yeah, it's cool that it was trying all that stuff. I could be wrong about that. Don't like quote me on any of that. But that's my understanding based on a quick thing that I read earlier this week. But yeah, so this was a cool project. It really shows the power of Qwen 3.8 27B. And then it also just shows, I think, in some ways, it shows all the stuff that community can bring, because just seeing all the other platforms that are getting better and better, and this is a little bit stuck here. Even like VLLM didn't work. I had to find some patched version from some rando, and I'm super appreciative of their work, but I wish that I didn't need to do that. I wish that I could just go to download VLLM. It supported this platform, this what is it? GFX, what is it? GFX 1151. I wish it just supported that out of the box, but it doesn't work today. AMD's not on top of things. They're working on it, but they're working on it from the high end going backwards, and they don't really seem to care about this chip as much. So yeah, we'll just see how it goes. I thought this was a really fun. I will be completely honest with you. I did not expect it to get to the end and do this. I thought at some point in the middle, it was going to compact weird. It was going to get off track. It was going to lose track of something. Like it really did scatter a bunch of info all around. I thought it was going to lose track of stuff. And I just thought we wouldn't get to a solution or an endpoint that I liked. The fact that it created a document at the end that was good, I got to say, pretty impressive. But okay, enough of that. That's enough of that. So that was last stream. That was the result of the whole 6-hour stream. The first thing I want to start with today to talk about is this Marin training run, because this is, in my opinion, one of the cooler things that happened this week. And so I'll just kind of like, I haven't really looked into this a lot. Like I briefly looked at it. So I'm not speaking from a position of expertise on this at all, except the fact that what I have seen is super, super, super cool. So this is a project which I actually had like maybe heard about, but I don't think I really knew exactly what it was, which is basically a fully open, community-supported pre-training run. And they're doing, what they're doing is openly training what they hope to be are quite good models. And so if you look at like what they've done so far, this is a pretty cool picture because it shows like, okay, they have a 1.6B model, which is this one that they've already finished. It's only activating 61 million parameters in every forward pass. So like this is like a small model. It's a 1.6B, but it's a mixture of experts. And so like this is a pretty good training curve for a mixture of experts model, meaning they've figured out like a lot of things. They've figured out the right data mix. They've figured out the right stability mechanisms for making their mixture of experts, their experts distributed correctly and make sure that there's no hotspots. But then what this shows is that they've taken that recipe and they've been able to scale it. So they took that 1.6B recipe and trained on 48 billion tokens. They expanded it. They created a 4B parameter model that activates 162 million parameters forward. And they trained that on 128 billion tokens. And so you can see that like it scaled. It did a good job. It didn't have a crazy loss spike somewhere where it never recovered. And you can see if you look at some of these training runs, they don't go as smoothly as this. So they've been scaling up. They did a 11.5B run that looks to be finished as well. And currently they're training this 27.7B one, which is it's starting to get to be that same size as like a Qwen 27B. But this is a mixture of experts, so it's only activating 1.2 billion parameters. So this is going to be a really, really fast model. It's all just very exciting. And you can see that like this is extrapolated. This has not been trained yet here. So they're still working on, like, this is still under training run. And what is super cool, this is the part that like started yesterday and is really exciting, is that they are starting training on what they quote as a hero run, which is a 535 billion parameter total with 23 billion parameters active. So this is starting to be to the point where like your everyday computer cannot just run this. I'm lagging. I'm really lagging. I don't know what to do about that. Let's just see if it gets better over time. Ooh, it's lagging. Oh, it's because my CPU is at 95 degrees, 97 degrees. Oof, oof, oof. Let's see what I can do about that. Is there anything I can do right now, quick? You know what I can probably do? I think I can get rid of the blur behind me. Let's just try getting rid of the blur. Let's see if that makes it any better. Not much. Oof. Sorry, folks. Trying to think of what to do. I think it's because it's getting hot. It's hot in here. Maybe what I'll do is just open the... Here, let me be right back. I'm going to open some of the windows here. Okay, is that better? No, it's like even worse. I also changed my turbo settings. So I need to turn those turbo settings back on, I think. How's this? Testing 1, 2. You know what? It looks like it's actually getting a little better. We'll just hope. Well, we'll just go with this for now. So yeah, anyway, what's cool about this is this hero run of a 535B parameter model, which you've got 23 billion parameters active in every forward pass. That's starting to be like, remember when Qwen3.8 27B it's a dense model, so it's not going to have this 535 billion parameter capacity. But so we're talking about like the speed of the 27B. It's not that different from a speed of a 23B. Depending on, there's many different things here. I mean, the number of active parameters is not necessarily indicative of the speed, but like that's just a rough mental picture that you can have. But yeah, so they built this whole, they plotted this entire curve before they started. That's what's so cool about this, is that they're so confident in their scaling laws and in their extrapolation abilities. They're so confident in the ability to sort of extrapolate from what's happened in all the other data points that they're plotting this ahead of time before they even start their work, which is pretty impressive. And then yeah, so those are the eval curves, I believe. I think these are eval curves, and this is the actual loss curve. So you can see this is the depth 2048, which is that. Oh, if you look at the colors, green, light green, dark green. I think it's not matched. I think this is the hero run. You could look at that, how deep the loss curve on the hero run is. So this is like, that's super exciting, right? Like it's gonna be a lot lower. But and I guess I was looking at, this is like where they changed their data mix over here. That's why it kind of jumps up. But I don't know all the details. But okay, so this looks like this is the 1.7B total. This one, the pink one or orange or whatever that color is the 4B. This one here, it looks like it's the, what is it? 11.5B. And yeah, this makes sense because it's not finished training yet. And they have this whole, it's not finished training yet series. So this 27B parameter model looks like it's this the depth 2048, which makes sense because I think a lot of when a lot of these LLM companies are training their models, they think of them in like the depth of it. And I'm pretty sure the Hero run, they don't put the depth in here, but I think it's like 60. It's 6,000 something. So it's like way deeper. But what is really cool, so first of all, you can download their data. You can first of all, you can explore their data. Like they give you a whole mix of, and you can open everything. This is the cool button here, just like opens it all. But it shows you the mix that they've chosen. So I think when this says lowest, low, middle, high, highest, I think these are quality levels. Because if you look at and you see the mix, these are open source data sets, and you see the ratios, the ratios at which they mix those in. So this HPLT seems to be like their biggest mix for the lowest tier. And then fine translation seems to be their greatest mix in the highest tier. And it's cool as you can like see. You can actually like see examples of this. It was just like a cool project. This is a really neat project. So, but that's not it. And you can see, okay, games and gambling, schools and children programs, study skills and academic writing. You can see just like all the different categories they have here. And one of those here, let's like go to software development. So it looks like in the lowest tier, we've got the stack, which is just web data. This is just, I think that's web data. The stack, E3. What is it? Oh, it's source code. It's source code. I actually thought it was random internet data, but it's source. Oh, I'm thinking of the pile. The pile and the stack. Okay, but the stack makes sense. So this is just a giant database of all source code that I'm sure that they could find from anywhere. And then as it gets here, the highest quality one is Nemotron CC code, which is Nemotron. We have so much to thank the NVIDIA folks for because they open source just so much of their data. Like, I mean open source when I say it, because a lot of companies just release open weights and they don't release all the data that goes into their stuff. But NVIDIA has released not everything, but a whole lot of their data and the recipes for how they generate the data too. But so it's cool that you can download this. Like you could literally download all this data if you want, which is great. It's super cool. But then this is what I was like I was really like kind of like geeking out about, is that you can watch the run live. Wait, where are we? So you can see like as the hero run trains, this is the loss curve. Oh shoot, it's like yeah. So this is the loss curve of that hero. This is what he posted yesterday. This is updated. So I don't know where this was yesterday. Let's see. It was like 1 point, I don't know, 6 something. Where are we at now? Yeah. So we were somewhere around here yesterday, and now we're here, 1.39. So it continues. And look at this graph. Like when you see it, normally when you see these loss curves like this, you see like little spikes, little spike here, little spike there. And the problem is that like whenever you see those spikes, oftentimes it doesn't go back to the same baseline. It's like goes back to a higher baseline, which you don't want. And then you get weird damage to the model. But this means that they've found such a good data mix and such a good training recipe that they just have like the smoothest loss curve ever, which is super cool. And this is live. So you can go back here tomorrow, next week, days from now, weeks from now, and see as it finishes its training run and watch it. And like there might be problems. Like if something goes wrong, they're gonna have to fix it and solve it, and you'll be able to watch it as it goes. But so this is cool. Like for example, they have a ramp up of their learning rate, and you can see we're already past the peak ramp up stage. So now we're in this like cool down phase of it, or in like the normal, I don't even know what you call that phase, where the learning rate just slowly drops and follows that pattern. And then yeah, this was so this is where they got that picture. You can see it starting to bend a little bit. So this is yesterday, and now it bends a little bit more. So cool. You can see the grad norms, And I believe this macro loss was the same thing that was driving this chart here. So, okay, wait. I wish I could hover over this and see what their prediction was. I'm sure they have it somewhere. But yeah, I don't know. So this is cool. So when this is finished, you can download this model, as I understand it. And then the other thing is, one last thing, on GitHub, you can see that they have all of the planning and all of, like, you can see where they fit those curves before. Oh yeah, and this is where I was saying. So this is like where I said that it was 614. I was saying it's like a 6,000 depth model. You can see that right here. And yeah, you can see also how they're scaling up the tokens. 18 trillion tokens for this one. Man, I'm so excited. Oh, and yeah, so this is the code. This is the code. Grug model config. Oh, that's fun. I actually didn't see that. So yeah, it's all open source. Literally open source. Literally. Not open weights, but open source. And I think, I don't really know much about this Marin project. Wait, let's go to... Yeah, and by the way, there's people, like, this is an exciting project. People are pumped about it. And I think we're going to get a lot of learning out of this. But, what was I going to say? Oh yeah, like this guy, the Marin project, he's got a link here. I was just clicking around in the Marin project, which seems like it's kind of a cool project. And their launch announcement is basically just saying, look, we're trying to create foundation models and we want it to be open. But the cool thing is that they have, like, Marin seems to be kind of like a library that you can use. So they have like a getting started guide, and you can get started right away. And like they have this thing where you run your first experiment, which I don't really know. I don't really understand how this fits in with the rest. But anyway, I think this is a cool project. I want to learn more about it. I want to, like, keep watching. I'm gonna keep going back to this weights and biases graph and just keep watching it as it goes, because I have a feeling this model is going to be impressive when it comes out, and I also have a feeling that it's going to be useful. Imagine running this on, like, I don't know, like, imagine taking a quant of this once it's finished and running it and, like, pruning it maybe so that it can run on one of these, like, D-Sparks, one of these DGX Sparks. And also the open source people are into it as well. So I don't know. In general, I'm pretty excited about this. I think it's cool. And it's also just, like, super, super ballsy to predict the loss curve before you start your trading run. That requires a lot of confidence. But I understand why they have that confidence based on just, like, the smoothness of their loss curve so far. Oh, there's a mailing list. That's kind of cool. Gotta ask. Okay, maybe not 100% open. But yeah, sorry, I never scrolled down here. But this is where they actually were making these predictions. They talk about, like, how they're doing their fit, how they're doing their scaling ladder analysis. Yeah, okay, and then this says data mix phase 2. I don't know what that means. But again, like, it's all open source. I could go look up what that means. Oh, here we go. Here's the full source to reproduce the scaling ladders. Yeah. So this is a really cool project. I'm excited to watch it. And I actually think we'll get something out of this that we'll want to use. That's my prediction. And of course, like, since the data source all the data set is open, because this data set is completely... Okay, wait. Quality score cutoffs. Interesting. Agentic, code, default, math, multilingual, and prose. Yeah, so you could train your own model with these if you've got enough money. But the big story of the week, the big story that I've been tracking, at least a lot of people have been tracking, has been this OX or OX, 0x. I can't tell if it's 0x or OX. I think it's OX. But it's this stealth model that was released on OpenCode, on News Research. Okay, first of all, the first one that I saw to host it was OpenCode, where they announced it would look 1:59 p.m. on August 20th. Then the next one that I saw to announce it was OpenRouter, which was, okay, wait, 1:59 2 p.m. Okay, not that much later, but I saw it later. And actually, I think what was happening is like for a while they were hosting. OpenRouter was just routing to OpenCode. I'm not sure about that, but it seemed like that was what was going on. But now, let's see what's at now. No, okay. I don't know who's hosting it, but anyway, yeah. There's this. Oh wait, and then the third one, which is news research. And by the way, there seems to be this escalation of. They say first OpenCode said we have capacity for 100 trillion tokens per day, which seems insane. That seems like a lot of tokens for this type of a model. Well, it depends. Like, is this model good, right? Like, if it's a tiny model, you can have a tiny model that has a million context window. But 100 trillion tokens a day is a lot of tokens to be able to have. So I think that just like, first of all, surprised people. But then, I guess OpenRouter didn't say anything about the amount of tokens they have. But then news research, they say, we have capacity for 1 quadrillion tokens per day. Let the tokens flow. So what the heck? What is this model? What is this stealth model, Ox Alpha? And is it good? Is it good, right? And so people are trying to figure out, because nobody knows who's hosting, who created it, and then who is hosting it. Who has the capability of creating a model that would capture people's attention, and then who has the capacity to be able to run it like this. But also, they're not, according to OpenCode, 0 data retention, which seems like if you're doing a stealth model release like this, you would think you would want to have data retention so you could like fix any of the issues that crop up with it, or training, or like check for malicious use, or how often it could be jailbroken. Or the thing is, it's weird that they would offer this free. By the way, free. So whoever is hosting this is doing it at some significant loss, and they're not training. They're not keeping data, so it's not like they're going to get some ancillary benefits from this. And yeah, 100 trillion tokens a day, or a quadrillion tokens a day. Like, what the heck is this model, right? But the point is that if it's bad, then who cares? But wait, what is this speculation thing I thought of? Okay, so this is where people are starting to, like, all this stuff that I was just talking about, where it's like, what is this model? What is this Ox Alpha model? And there are a lot of different speculations about it. Like, somebody said, first of all, people are trying it out and seeing how good it is. And this was one of the one-shot demos that someone did. Somebody was saying it's probably a new Kimi model. This is not a popular sentiment. What are they saying? A new Kimi model, likely K3.1. But this tells you the level at which people are kind of like finding this model to be. If people, I mean, Kimi K3 is quite a good model. So if people are kind of trying it and thinking it feels like a K3.1, but this seems to be, oh wait, this is different. They're saying this is on Code Arena. But yeah, this seems to be the biggest sentiment right now, is that it's probably a GLM 5.3 based thing, whether it's 5.3V with vision support, or 5.3 Flash or something. But if you look at the benchmarks, if you look at some of the benchmarks as people have tested, like, it beats Fable, it beats GPT Soul. So it's very hard to square that with the idea that how could this be a 5.3 Flash model if it's beating Fable? And yeah, so the question is, and like, so people are like, is it Mistral? Is it a 5? This is the other thing people are saying. Is it a 5.2 post-train? So GLM 5.2 launched reasonably a while ago now at this point. Like, GLM 5.2 has been out for like a couple months. And so there's a possibility that a third party took the GLM 5.2 base, further trained it, and then whatever this model is a result of that. So that's also possible. There's also been a lot of people claiming that it might be Gemini, because the Gemini folks have been like vague posting. Let me see if I can like me see here. I don't have good examples, but like people are vague posting about. Oh yeah, here we go. So this is like this is a selection of people from Google who are saying like, what if the Ox Alpha was the friends we made along the way? And just saying Gemini and saying it's Gemini time. Google is back. Trust the process. So it probably isn't Gemini. It probably isn't Google. It probably is just that they're excited about some model they've got coming out as well. But it just so happens to be, aligned with what's going on right now with this Ox stuff. So anyway, I've been playing around with it. I've been trying it, and so like I don't know. I've got it set up with Pi. Let's do something with Pi real quick. I don't even know what. Let's go to Mini OpenEnv. Remember that I talked about this project a couple weeks ago, where it was like a re-implementation of OpenEnv in C in a way that like helped me figure out what the actual protocol of OpenEnv was, because I was struggling with figuring out what the actual protocol of OpenEnv was. So let's go to Pi, and right now I have. So first of all, let's just say like, this is my Qwen 3.8. So this will be a comparison. Sorry, let's see if I can scoot it up. Yeah, so this will be a comparison of Qwen 3.8 27B, and let's just do it in another C development. And in this one, I will do Ox Alpha from the news portal. So what is this repo? Please don't just read the documentation, but also read the code. Give me a one-page document that you call document1.md. If you see document2.md, do not read it. And then that's it. And then over here, I'm going to say the exact same thing. Wait, I want to do it exactly the same. So I'm going to say, okay, if you see document1, do not read it. So this one's going to be going from Qwen 3.8 27B. I'm going to create a document, and we'll see what it does. And then this one's going to be using the new Ox Alpha. Oh, wait. Crap. So I'm on low. Do I want to keep it on low? No, let's put it on like the highest. Let me move to high for Ox Alpha. And, oh, crap. X high. And then on this one, Ox Alpha, it looks like it only goes up to high. So we've got X high, and we're going to do the highest thinking on settings on both. What is this document, or what is this repo? Stored in document 1, stored in document 2 for Ox Alpha, and stored in document 1 for Qwen 3.8 27B. And so we'll just see. This is Qwen 3.8 27B on my other computer. Let's just like make sure. I'll just confirm that we are inferencing. This is us inferencing on my desktop. So I'm proving it. And then here, it's starting. Oh, I forgot to do new on this one. It's probably fine. I'm okay with that contamination. This isn't super scientific. But while that's going, I'm going to go to Mini OpenEnv, and I'm going to open it in code. And so yeah, while this is going, if you remember what Mini OpenEnv is, I recreated, actually let's see if I can pull up the web page. So yeah, this is like a annotated pedagogical implementation of OpenEnv where I really tried to figure out what was it? What is the actual protocol? So that I could re-implement the protocol. Okay, looks like Qwen 3.8 27B is already writing, or it has written. And let's look at just like, oh wait. I thought I could do context. What's so funny is I'm actually not like, oh, here we go. I'm actually not a huge user of Pi interactively. Like, I actually don't use Pi that much except out of these streams interactively. I script Pi and I use like Pi's SDK more often than I use it interactively. So I'm like not the biggest power user when it comes to like the actual development experience using Pi. But okay, so this did 36 messages. 2 of them were just mine and from the user. Did 20 tool calls. Used 331,000 input tokens and 5,000 out. And here, okay, this is done too. Let's see. What was it that I ended up? Session. So this one, it did way fewer tool calls. Just 17 tool calls, or 17 total messages, 7 tool calls, 7 results. This was 20 tool calls, 20 results. This one used only 66,000 input tokens and output 2,000. This output 5. So this was like way fewer tokens. That's actually kind of interesting. I wasn't really expecting that, to be honest. Now we've got document 1. Document 1, remember, is our Qwen line. And document 2 is our, oh, interesting. It's a lot shorter. Qwen output 81 lines, and this new Ox Alpha output 59 lines. So now let's do, I'm going to use codecs. I'm going to use, I want to X high. I'm going to say read document 1 and document 2 and tell me and compare and contrast them and tell me which one is better, more accurate, more complete, etc. And then I'm also going to do this again, but I'm going to swap the order. And I'm going to say read document 2 and document 1. Because ordering can matter. It can really matter a lot in these like classification things. And so we're just going to see if it comes to a general consensus. I mean, I can read with my eyes too. Let's like do a little bit of that. Imagine that, right? Okay. Mini open-end. What this repository, this is Qwen. One line, a complete reimplementation of Hugging Face's open-end protocol in dependency-free C99 derived from captured wire bytes of the Python reference rather than from its documentation. Verified byte exact, corpus replay, and by Hugging Face's own client and validator. Okay, what the protocol is, blah, blah, blah. Like this is actually talking about the protocol itself. And then this is talking about architecture, 4 layers, separated by CMake check. Okay, wire, the protocol, the server client, and then like the include, the authoring API. Right? Writing an environment is small in both senses. And Echo C is a complete conforming server. 2 field tables, which are the schema, 1 state struct, 3 callbacks. What ships besides the library? Examples, arcade, interop, tests, and reference. The point of the repository. The project's stated answer to a real confusion, built on the protocol versus built into it. Every public declaration is tagged wire SDK policy, make docs, blah, blah, blah. So this is true, although this is a little bit obtuse way of saying it. Okay, so now let's read the Ox Alpha one. This is a little bit less, this is kind of informal. What the repository is, kind of like a little bit cutesy. But this here, Ox Alpha says, Mini OpenEnv is a dependency-free C99 reimplementation of the OpenEnv protocol. Hugging Face's standard for serving reinforcement learning environments as services. Reset, step, observation, reward. That's kind of nice. I like that it gives that like 3-step thing. The Python reference implementation is 750 files, so it gives us a general sense of the size. This repo isolates the protocol buried inside of it, which is a fork. This is kind of a little bit better of an explanation. How the code is organized and why. The tree enforces a layering discipline. Make check. Wire, proto. Yeah, because I was wondering, it said there's 4, what was it that it said here? 4 layers. But then like in here, there's server client. Over here, it doesn't try and say that there's 4 layers, but it says there's a wire, there's a protocol, there's a server, there's this include. This is pretty similar. But then this also includes the example environments, the arcade, the examples, and then all the other stuff. Okay, that's like relatively similar. Key design ideas, byte fidelity over elegance. Hey, come on now. I cared about elegance. The goal is reproducing observed behavior exactly, including protocol oddities. Yes, that's true. That's true. That's what they're trying to say, is that like we re-implemented all the words. We wanted to match exactly. Enforce separation of protocol from framework. C as an anti-paraphrase device. Yeah, did this say anything about C and why? I don't know. Radical minimalism. Yeah, C99, no dependencies, one file portability. Yeah, that's true. Documented under specification. In short, it's simultaneously a faithful embeddable OpenEnv stack in C, a debugging interoperability toolkit for any OpenEnv deployment, and a teaching artifact. Honestly, this was shorter. It was a little bit less in depth, but I think I like the things that Ox Alpha said better than the things that, like, this was a little bit more in depth, the Qwen3.8 27B, but it's a little bit less human oriented. Like, as a human reading this, I actually have a better experience because I feel like it put things better in context. Like this, for example, like this little quick little indicator about what this is. It's like going from reset to step to observation. Like that's pretty good. Okay, let's take a look and see what Sol thought about this. Okay, this says document 2 is the better document as written, clearer, more concise, and less error prone. Document MD1 is substantially more complete and technically informative, but it contains several incorrect, stale, or insufficiently qualified claims. It would be the stronger document after revision. Oh, that's an interesting observation. Okay, accuracy, document 2, fewer incorrect. What are the incorrect specifics? Let's see. Reference vendor copies is false as a repository claim. The directory happens to contain ignored checkouts locally, but no files under it are tracked. Yeah, that's true. I did. I told it to git ignore a directory, and then I said check out OpenEnv there, like actually Hugging Face's OpenEnv. So this got that wrong. That's true. It saw the directory, but it didn't see the context around it. That's crazy too that it did it in so many fewer. Like this took a lot more calls and tool calls to get there. So that's kind of interesting. Wait. Okay. What else? Completeness document 1. That is pretty evident. Readability document 2, that's what I said too. I'm glad I judged this before I read its judgment. Technical usefulness, document 1. Yeah, okay, because it's just more complete. It captures important wire level behavior. What is the wire level behavior that this captured? The envelope. Does this talk about the envelope at all? No, it doesn't give any specifications. So that's different. Okay, so this was the first one. Overall, as is document 2, safer and more effective introduction. And then recommendation, use document 2 as the foundation, then import the strongest corrected material from document 1. Okay, now let's see what it did when we had it look in the opposite order. I started it looking at document 2 first and then document 1. And this says, verdict. Use document 2 as the base. More accurate is written document 2, more technically complete document 1, clearer and better organized document 2, best for implementers document 1. Yeah, because it has the actual envelope. That's more useful for an actual implementer, I suppose. Clearer and better organized document 2, best general repository introduction document 2. Okay, so very quick test. Like, this was not a good test, right? It's just a nothing thing, right? But like, actually, it's not, because being able to efficiently and correctly assess the context of a coding environment from nothing is actually a really important skill. And like, what to look for, what to bring into context, what to do there. And then how to, again, like, actually, I hadn't really expected this to be so much more efficient than the Qwen model. Actually, let's do something, no, never mind. I was gonna say, let's turn them down to low and see. Should we? No, let's not do it. It like, we saw what we needed to see. Let's see, what else can I do of like a cool experiment to run on both of them. I could do like a one shot. I hate how, okay, here's the thing. Like, I would love to test out these models. What everybody does online is they do these one shot tests that are very visual. And it makes sense why people do that, because if you have it generate a website, or if you have it generate a game, or if you have it generate an image, like, those are all these very visual ways for you to be able to see, like, how complex did it do, or how complex of an artifact was it able to create. And then the more complex that artifact, you know that it had to do a lot of tool calling, it had to do a lot of like revisions, and usually it doesn't just one shot and just output the result in without doing any sort of tool calling. Like, usually it has a trajectory where it thinks, it does some part of it, analyzes that, it outputs some more, it edits what it did, it thinks more, maybe it deletes, or it pares down some part of what it did. Maybe, like, if you're using certain harnesses, it will like spawn sub agents to do things, and to do some adversarial checks and loops and things like that. But ultimately, you end up with like a very visual artifact. But the thing is, like, that's not the only thing that matters. Like, I find that I don't often do these very visual things. Sometimes I do, but a lot of what I'm doing is like data management. Like, if I create an orchestration thing for orchestrating my own agents, or so maybe that's what we should do. Make like a little, what's a data project that could be fun to do? Do I have any data that we could? Oh, actually, I do have some data. Oh, I don't want to like get into it yet, though. I'm thinking about it. No, okay, I don't think I'm going to do it. Let's just leave this for now. This was a good test. Oh, but Ox Alpha is so interesting. It's such an interesting model. Okay, one of the things that Ox Alpha can do. So I've been using it in. I don't know if I want to say what I've been using it for yet. But one of the things that I've been having it do is develop some software, take screenshots of that software, read those screenshots back, and judge the output of the screenshots. So let's do something like that. I'm going to close this out. Let's create like a new project, and I'm just going to do that visual thing, right? I'm just going to do a visual thing. Let's do this. Let's do 3D modeler. Let's do that. So let's do 3D modeler in this project, because we want it to be visual, and this is kind of related to something I'll talk about later. So let's create a document. Actually, I'll start a new thing here. I'm going to create a new document, and let's call it initial instructions. And actually, I have this new, I'll talk about this actually later as well, but I have this new audio software where I can speak, and it will speech to text, so I'm going to use that here. This is an experimental repository where the only thing that you get is this document as instructions. Everything else after this, you will have to generate, create, test, validate, improve, scratch that, validate and improve, yourself, period. This repository is going to be about taking in a user description and outputting the best possible 3D model matching that description that you possibly can, period. The only thing that you have to use to do this model is access to an agentic LLM and 3.js, period. As an aside, I think it's hilarious that it said 3.js. I'm going to change that because... Okay, so, and I'm going to capitalize this. So the flow is this. The user types in their description of the 3D model that they want. And then you go off and call an agentic LLM, and you can set that up however you want it to be. But in the end, it should show visually to the user a 3D model that matches as best as you possibly can to the 3D model that they requested, period. So yeah, oh wait, I thought I turned it off. I did. So this is a very open-ended thing. I have no idea how well this is going to work or if it's going to work well at all. But so, okay, actually, let's do this. What I'm trying to do is I'm trying to say we're going to have Qwen do one, and we're going to have the Ox Alpha one do one. But how do I tell? Let's see. I think what I'm going to do is just create Ox Alpha and Qwen, and just copy this in here, so that we don't have to worry about any other issues. Okay, so let's go to Ox Alpha. Oops. Qwen. So let's see. First of all, we'll do the Ox Alpha one. I think this is still set up. No, this is the Qwen. So wait. It's already set up as Qwen. And so in this, I'm just going to say, please read, or here, goal. Read initial instructions.md and continue development until you're confident it is complete. And now I'm going to go here and say pi, and we'll do model Ox Alpha, news portal. Same thing. Read initial instructions and continue development until your confidence is complete. Let's see how both of these do. And we're doing a very visual thing, so we'll really see. And already it looks like my Qwen implementation is pretty good at this point. It's pretty fast. I've got it dialed in. And because of a lot of the stuff that I tried last week, where I had it going overnight trying to find its best configuration, I think it's actually found a pretty good one. So it's going. And then Ox Alpha is also going. Wait, it read the instructions from the parent directory. That's interesting. Oh, wait. It said the local one is empty? That's not true. Oh, I didn't save. Wait a minute. Sorry. Stop. I didn't save. This, I'll just delete. And then I'm going to just do it again. Crap. Okay. I'll start this one first, because it's Ox Alpha. Oh, crap. Do I still have it in the paste buffer? Yeah. Okay, read initial instructions and continue development until you're confident it is complete. And then here, I'll do this again. Desktop GPU. There we go. There we go. I was able to read the initial instructions this time. And I'm going to confirm again. This is actually inferencing on my other desktop. It really is. The Qwen is really running on the other desktop. I'm impressed with the tokens a second too. Between 50 and 60 tokens a second, 64, 67. It's interesting how wildly it swings, like between 44 tokens a second and 67. Like that's, or 68 even. That's a pretty big swing, and I think a lot of that has to do with the multi-token prediction and how much multi-token prediction is working versus not. But I'm closing that for now. I wonder if I should have done them both on low, just so we can get done faster. Do we have any users in chat? Nope, just me. Wait, it says 3 viewers, but nobody in stream chat. That's interesting. I didn't know that was possible. So this is clearly going to take a bit. I am actually really curious now how this is going to go. This ended up being kind of a fun test. Because it's probably going to be terrible. Both of them will probably be terrible. And I also wonder, like, I do have random, like, API keys in my environment, but it's like I have a bunch of random API. I'm not going to print them out or anything. Here, let's see. Let's do that. I'll do hi. What LLM API keys do you see in my environment? Don't print them out. Just enumerate them. And this is using Qwen, using my desktop. So it's probably going to wait until, like, it's probably going to, like, fight with it a little bit. Actually, let's not do. Let's do V4 Flash. Using DeepSeek V4 Flash. Oh, it's just listing these all out. So, wow, okay, I've got a bunch in context. So, Anthropic, Anyscale, Cartesia, Claude. I don't think this one is still good. This is probably some ancient thing from when I was trying stuff out. Deep Infra, Folk Reel, that's my own service. Gemini, Grok, HF token, Mistral. So it's got tokens to use if it goes and wants to, if it decides to go look for them. Let's watch in here. So Ox Alpha, it's already started doing stuff. That's interesting. Qwen has not. Oh, it's thinking. It's like writing it all in thoughts. And then I guess it'll transcribe the stuff it wrote into files. So that's interesting that Qwen is being more cerebral. It's doing more in its own thinking patterns first before writing it down. Whereas Ox Alpha, it's like writing right away, and we'll see if it edits and it like continues to carve out what it wrote. Claude Sonnet 4.5, that's weird. That's interesting. That's kind of an indication. Like sometimes the models that your model chooses to use gives you an indication about when it was trained. What is its training data? When was it trained? What is its base model? What is its post-training data? And it's interesting that this seems to be like its defaulting is to Sonnet 4.5, which is a while back now. That's just interesting. Oh, Qwen has started writing stuff. Ox Alpha got to HTML faster. But yeah, so it's my guess. Okay, I wanna while this is going, I want to give a conspiracy theory about it. So everybody basically thinks right now that this is GLM 5.3V or 5.3 Flash or something like that. Let's just go to like the GLM Hugging Face. A lot of people seem to think, wait, GLM 5? It's interesting that GLM 5 got updated, right? Why did GLM 5 get updated recently? Let's see. Oh, they added community evaluation results for Sweetbench. Okay, so multilingual Sweetbench got 73.3 from the community. So, but check this out. There is precedent for a GLM 4. A GLM V model with the vision capabilities in there, because GLM 5.2 doesn't have vision. But this model here, this Ox Alpha model does have vision. So clearly, it's not GLM 5.2 itself. It could be GLM 5.3, but it's probably a GLM 5.3V or GLM 5.3 Flash or something like that. That's what most people seem to think right now. But I actually think that there's a chance that it could be another model company, which is here. Let's see if I can find the Meituan. I don't know how to say Meituan, but I think there's a possibility that it could be It could be Meituan Longcat, because they are no slouches at post training. They have had their own models that have been quite good and have done very well at coding and agentic things. As well as they also know how to do, they put a lot of effort into doing things they call omni models, which is similar to what Google calls omni models, which is like being able to take in video, images, I think audio, and text, any of those modalities, and reason about it and output text only for now. And I don't think that Ox Alpha is a continuation of any of Meituan's existing Longcat models, but I think it is possible that Meituan took a GLM 5.2 or an early checkpoint of 5.3 if they're coordinating with ZAI, and I think I think there's a possibility that, oh wait, I can expand this out. I don't know why I kept it so, anyway. I think there is a possibility that they took their post-training that they provenly did on Longcat, and it provably created quite good models, and they apply it to GLM 5.2. I think it's possible. I was going to ChatGPT with this one. I was saying everyone is speculating as to who might be responsible. Wait, also I went to Claude. I was using Claude as well. And it was basically like, no, it doesn't think so. Everyone is speculating as to who might be responsible for the stealth Ox Alpha model that appeared on News Portal, OpenRouter, and OpenCode recently. Many people are speculating GLM. I did see one hint that it might be Longcat. There was a very vague hint from one employee of News Research that was saying, like, I think it was, here, let me find the tweet. I think it was News Research. Here, let's see. Was it their account themselves? Let me find. This was literally it. Someone said, haven't been rate limited on this one yet. It's really good. Who is behind this and how did they get all the GPUs? And they said, don't worry about it, kitten. Enjoy the unlimited intelligence. And then somebody else picked up on that too. They said, kitten, is it a Longcat model? And that's what like sent me down this whole rabbit hole of thinking about that, where it's like, it's probably nothing. It's really probably not that. But that's what sent me down the rabbit hole of looking into it. And so what did this say? This said basically like, no. My best interpretation is it's probably a GLM 5.3. But then what I said is, couldn't Meituan have started with a GLM 5.2 base because it's been out for a while and performed their proven excellent developer-focused post-training on it? And then they were like, okay, actually, wait a minute, I could see that. And then ultimately it said, okay, the thing that the most convincingly says no is the visual encoder matches exactly to the GLM 5.3, which hasn't been open sourced yet. So the only company that had access to the visual model or the visual part of GLM is ZAI themselves. But I don't think it's totally out of the question that they're sharing, that they're sharing information and checkpoints. But also people have really dug in, and it seems to be that it's ZAI. It seems to be ZAI. Longcat is, wait, okay, this is what I was going to say. My updated separation, is it a GLM backbone? Like, it's 90 to 95% guaranteed to start from being a GLM model. That's what this speculation says. But they say, is it actually from ZAI, 50 to 60%? Or is it a Longcat trained hybrid or some sort of different thing from a post-train, 25 to 35%? So that's pretty interesting. And then a lot of people are also saying it could be Cursor, or it could be basically XAI, because they have all those GPUs, and they could have started with a GLM base as well. There's no reason they've done it before, right? They did it with K2.5, I believe, for Cursor 2. But then somebody else said on Twitter, and I don't even know if they know anything. This is all just fun. But they said, let me give you a hint. The second zodiac animal. In the mythology of the Great Race, the generous ox agreed to carry the rat across the final river. Just before reaching the Jade Emperor, the rat jumped ahead, making the ox second in the Chinese zodiac. It represents stability, patience, and methodical determination. I don't even know if this has anything to do with anything, but then this was saying like, oh, that clue is actually just wordplay, and zodiac animal in is ZAI, and then the second ZAI, like the second ZAI. I don't know. Wait, let's look at the SZAI GRORJJE. No, I think it's like reading too much into this. There may be another deliberately planted acrostic a few words later. The generous ox agreed to. That spells goat. I don't think so. It's like seeing mirages at this point. Oh, wait a minute. The alternative Longcat interpretation. There is still a clever Meituan reading. In a common extended version of the Great Race, both the cat and the rat ride on the ox. The rat pushes the cat into the river. The cat therefore pushes the cat into the, the rat pushes the cat into the river. The cat therefore fails to enter the Chinese zodiac. That makes the missing cat potentially significant. A hint about Longcat would deliberately recount the ox and rat story while conspicuously leaving the cat unstated. Yeah. And then I did the same thing here. It said, first of all, it did the same thing where I was like, no, nuh-uh. I don't think so. Longcat causal LLM is totally different. Longcat's different. And then when I said the same thing, yeah, but couldn't have they started with a 5.2? And they said, and then Claude said, oh, you've put your finger on a real weakness in my argument. Let me check the load-bearing claim. Such a Claudeism. This is like, I can't stand Claude's phraseology. And I find myself saying him, too. Like, it's so catchy. Meituan's multimodal work is omni, audio plus video. And Ox Alpha exposes no audio endpoint at all. And the entire Longcat 2.0 pitch was a trillion parameter model trained on 50,000 Huawei Atlas chips with zero NVIDIA in the loop. Actually, that could make some sense, though. If it's a Chinese model, what I was saying at the top of this segment was that, like, why are they doing this? Why would they do zero data retention and 100 trillion tokens a day and make it free? Like, why would they do that? But what might make sense is that they're testing out the inference capability of their fleet of different kinds of chips. Like, that's an interesting thing. That would, like, make some amount of sense as to why they're doing this. They're seeing if, like, their inference could hold up. I don't think that's probably it, but it's like interesting. Okay, let's check in on our things here. My inline server was broken. Let's see if it compacted at all. Or no, we're at 88.2% of this one. Remember, I didn't change anything about my Qwen install. It's not the full install. It's this 100K token version that's running on my desktop. It's got quantized KV cache. This isn't totally fair, but this did so well in all my tests last week. I don't want to change it, and it's also reasonably fast. Whereas this like is a brand new model, so it's kind of like we're comparing something that I know is good and know that it works on my system and works in my. This is what I've been using, so it's kind of like a real world test. This is what I use when I actually want to use my own local Qwen. Whereas this is what we're given from Ox Alpha that we don't know where the heck it's from. Okay, this is cool. This is doing browser smoke tests. At least it's actually booting it up. It's rendered pixel verified. Did it read the? Oh, okay, wait. I mean, visually inspect the rendered model quality with a screenshot. You know, it scrolls. CD, but it didn't read the screenshot. I don't. Maybe it didn't work. So let's look at where we are here in terms of just like what do we got. The Qwen one already has a README. It shows Claude. I hope I have enough credits on my Claude. My Claude is like I keep using it all up. Same with Codex. Although Codex just reset, so I have more now. Sorry, this is Ox Alpha. Ox Alpha already has this README, and this is a pretty good. There's no like one of the things that you can tell from as LLMs get better is their ASCII art gets better. Like sometimes you'll see like a lot of these where it just like doesn't line up. It's so frustrating, and then you tell it to like do a revision and improve it. And even if it's Claude, even if it's like the newest Claude, sometimes it just like gets those wrong. Which, hey, if I'm outputting tokens instead of actual text, then I would get it wrong too. There's no way. These things are supposed to be superhuman. So Qwen looks like it dropped a server.js right in the root, whereas Ox Alpha is like creating a package. NPM. Yeah, this is like it created a public site. Okay, so what this did a public site too. I would say so far, Ox Alpha is definitely outclassing Qwen because dropping a server.js is not as nice as well. Let's see. It's like 190. Yeah, this is a better implementation because it's like split up across files. This is the agent. Oh, Claude Sonnet 4.5. I remember seeing that. This uses the Anthropic SDK, whereas what does this one use? It looks like this is using Deep Infra. That's interesting. This turned out to be a cool little test. I'm curious, like, how long it will take for it. Oh, okay. So we hit compaction on our Qwen model. Also, I want to show what compaction looks like. The Qwen model, this is what allowed it to do so well in that last week's test, was that compaction worked. It didn't get off track. And so I was reading some of the compaction outputs, and it's interesting because it really does spell everything out. It gave the original request, and then it's really good about just like detailing everything that happened and pointing in everything that happened out to where it can read more about that thing. So it's like inspected the repository at this exact directory location. Initially, it contained only this particular file that you could read. The environment, the live access to the models, designed and implemented a zero runtime dependency web app, server.js. Here's my client loop. Like it's cool to see this. Created these files, installed these dev dependencies. Qwen is doing a pretty good job at doing compaction. Context for suffix. And then, yeah, you can see it's got these like list of modified files, which is great. Oh my gosh, it's windy. And then Ox Alpha, we're only at 3.7% of our 1 million context window. We're probably not going to hit the context window here, at least not right away. That's pretty good. And our cache hit ratio is 98%. What's our cache hit ratio here? 99.99. That's really good. Okay, I'm gonna close these windows. I'm sorry, one sec. Okay, I closed one of two windows. Hopefully this like balances between my computer not overheating and like and the wind not coming in and like ruining everything. Hopefully there's somewhat of a balance there. But okay, so now we're back to like this is back to working now. Oh, I think Qwen just wrote its first README. Let's see. Qwen wrote its README. Okay. Hey, this is exactly what I was talking about. With like, it's just messed up sometimes with these models. But it's impressive how this one didn't. Although it did less boxes. But that's like an indication of something. Like training flops or something like that. It's like the more training flops you put in there on this type of a thing, you just get better results, I guess. It's my guess. But okay, an experimental repo that turns a text description into a 3D model by combining an agentic LLM with Three.js. Type something like a cozy little house with a red roof, white door, and a chimney. And an autonomous agent loop does the rest. Writes, renders, critiques, iterates, delivers. Models. It picked Qwen's. It's self-dealing. The coder. Qwen3 coder 480 A35V Instruct Turbo. Why did it pick Qwen's? That's so funny. It didn't even pick good ones. Useful envars. Okay, how the agent loop works. Public agent JS. Framework free, also importable from Node for tests. I like that actually. I'm not crazy about the fact that this imported from like Anthropic, but it honestly, if we're results oriented, the Anthropic SDK is the way to go. This like custom coded render loop and agent loop, framework free, which I like. It fits my personal aesthetic better. I'd rather just build it ourselves. If we're talking about just like being goal oriented and being sort of outcome oriented, that's not the best way to go. Oh crap! How's my video? Okay, it's good. Oh man, this computer is totally overheating. Whatever. Okay, so this is saying it iterates up to max iterations. It grabs a reply from the coder chat. It pulls out the code. It renders the code. What is this? Renders the code, takes screenshots of it, plus grabs stats, evaluates that, the shots and the description. Where's the description? Oh, I see. The original description. Best. So this is generating multiple. Picking the best. And keeps going until the score is greater than the threshold. That makes sense as like a general loop. That honestly makes sense to me as a general loop. Sandboxed worker. Oh, it's a worker. It's a web worker. Imports Three.js, evaluates the model's build scene, auto fits the camera to the model's bounds. That's smart. And captures PNGs from 2 angles. That's smart. You need to have this so you can get that critique loop working too. So this is impressive from Qwen. Like honestly, I'm still always impressed with Qwen. Qwen is just continually impressive, but this new model seems like it's even better. Oh, goal complete. Qwen says it's done. All requirements verified. Final audit against the initial instructions. Start it on port 1257. 1258. This is still going for sure. Although it feels like it's been... No. Okay, it stopped its own server. Okay, live it. So the Qwen one is done. Ox Alpha is still going. So let's look at the Qwen one. Qwen 3D Modeler. Type a description. Agentic Qwen loop writes Three.js code, renders it, critiques the screenshot, iterates until the model matches. Well, it's got these like defaults, which are kind of cool. Max iterations, so we can kind of like put in perspective. Let's just do this cozy one. I'll save this for later so that I can try it on the other one. Let's try it. Generate model. Oh, it's gonna generate the code. I was wondering why it was like extracting code. Looking in here, I was like, why is it extracting code? It's because it's not writing. I thought it was gonna like, I thought Qwen itself in this process was gonna generate like the Three.js rendering code, and that the only thing that the agent was going to do in this loop was generate like the 3D model, the vertex data and the 3D model, and then have an engine that loads that in. But it actually kind of doesn't completely suck to have the model generating 3JS directly, like the agentic loop generating 3JS directly, because you can do like programmatic stuff with that. You can like write shaders, and it might. And oh my gosh, that's cool! It created a little house. It's like not that great, but let's. Okay, it said accepted at iteration 1, scored 95 out of 100. Let's make that a little bit harder. 99. It's okay. Iteration 2. We got to a second iteration. Iteration 3. This is cool. Oh, iteration 4. This is the max. I wonder what it's going to do if it doesn't pass after 4. Oh, okay. It gave itself like a weird. Wait, what did it end up saying? I wish that. Oh, that's cool. I didn't get to see this. Evaluated, score 75. 95, 95. Oh! I like the little chimney with the spheres coming out of it. And they got rid of it for the final one though. That's cool. But it's not great, but it gives us a sense. And I don't love how the scroll didn't work on the left. But whatever. This is a one-shot test. This is what did we get from a one-shot. And Qwen, it's not the best. Like it could be better. It could have chosen better models. It could have done a better job with like the UI placement. It could have done a better job at feeding back the feedback into the loop. I don't get a sense that it did that at all. And like there's a lot of things that could be better, but this did. It absolutely built the thing I asked for. It absolutely did. Oh, wait. I'll bring it back so that we can try it against. Okay, how's this one doing? It's killing itself again. Seems like this is actually struggling a little bit. When you see this happen where it like the goal comes back in, that means it tried to stop. It ended its turn without saying goal complete. And so then this is the goal system of the harness reminding it to keep going on the goal. So that's bad. It's done that 7 times, whereas this, it never had to do that. Let's double check. No, it compacted. Yeah, it compacted, but the goal never had to come in and like remind it to continue on its goal. So that kind of sucks. And this is taking a long time now too. Like, what's it doing? I'm not totally sure what it's doing. It's probably just inferencing. I think one thing that might be going on too, I've been trying this over the course of this model, Ox Alpha, over the course of the last few days. And it's gotten like better and worse in terms of, I think there's a lot of people that are using it right now. I think there's a lot of people that are trying it out, and they're sending lots of traffic towards it. And, you know, it's a good test because you really will find out how your inference stack can hold up. But at the same time, I think like the inference stack isn't always holding up great. I've had to do a lot of like proceed, up, enter, proceed, up, enter, proceed. Yeah, it had to do it again. It tried to end its turn. You know what I'm going to do real quick? I have another provider. I have the open code, Ox Preview F3. Okay. Now, one thing that sucks is we're going to just totally tank our cache hit ratio on that because we're switching from providers. But let's just see how that does. Unfortunately, this is kind of indicative of the experience I've had so far, where it's like, it's great. It's a high quality model, but the inference experience with it has not been good, no matter which provider I go with. There's been a lot of just like, especially I noticed it getting the worst when my model had gone into, ooh, my laptop is really struggling. My model went into a couple of these loops where it's like it tried to render a bunch of things and then read the renders and then act on those renders. And after like 4 or 5 images made it into the context window, like I almost couldn't get it to continue. Like it kept crashing, or it kept like, it was giving 503s for a lot of times. And then after a while, the inference providers pushed a fix where it wasn't 503 anymore. But then it was like giving, I was only like 4 or 5% of the way into my context window, and it would say like I've exceeded the context window. So maybe that's what's happening here too. But yeah, in general, I haven't had a great experience with the inference side of this. However, there's people online who have been saying, let's see, what is it? Ox Alpha Spark. Someone was saying that they have confirmation from the, open or Ox Alpha will be open source and can run on 2 Sparks. That's what I've been seeing around. I don't know who originated that, but this is the rumor I've been seeing around, is that it can run on 2 Sparks. Oh, cool. Okay, I actually wasn't planning on talking about this today, but I went to this talk the other day. I'll just talk about this now real quick. I went to this talk the other day. I went to this meetup at Planet Scale, and one of the talks there was about Rust. Oh, crap. It's a keynote. So I'm going to download it. Do I have anything that can open a keynote? I don't know. Let's use... I'm going to copy the keynote in here, and I'm going to say, I'm going to go back to Codex. I'm going to say convert this to an HTML page. HTML. Gotta love agents. We'll see if it can do it. But okay, wait. We're not doing this anymore. Not doing this anymore. Yeah, see? It's just these network errors are rough. Finish reason network error. That sucks. This model might be good, but it's hard to get it to complete its inference passes. So I don't know what they mean when they say that they have capacity for 100 trillion tokens, or that they have capacity for whatever, a quadrillion tokens. The quadrillion might have been a joke, but I don't know what that means if it can't seem to handle, like, this isn't, we're at 4.4% of my context. What is my context? Wait, what was it? Session. Wait, why is this saying 1.5 million? Probably from all the retries? Unless, did it compact? I don't think it compacted. No. Never compacted. So I don't fully understand. I don't know. It's a little confusing, to be honest with you, about what goes on here and why it gets to this point where it can't continue. It's searching the internet for keynote conversion stuff. Hurry up and wait, right? Let's see if I like close this. No, that's about. I need to fix this for next week. This whole streaming setup needs help. It's literally overheating. Oh my gosh, it's my laptop is so hot. I don't know why. I'm not doing anything crazy. I can't even move my mouse right now. This is not good. I really don't know what to... Oh, there we go. I don't know if it'll last. I honestly was just plugging my power settings differently. I have this thing called G Helper. Seems to be okay for now. Okay. Okay, so what do we got going on here? My slides are still improving themselves, and then let's check. See, here we go. I think I'm gonna this is my takeaway, is that I've tried 2 different inference providers at this point. I don't know why. It seems to get to a point where, and it's not always at the context window limit, it just gets to this point where it can't go further. It can't seem to go any further than what it does. No matter what I do, it can't correct itself. I guess I'll try one more time. I'll say proceed, or I'll say goal resume. And sometimes it works. When I do this, sometimes it picks itself back up and resumes. So I guess let's give it a shot. See if it can do it. Yeah, it did. See? So, oh wait, it says the work is essentially complete too. So that's good. We're almost done at the end there. This thing is still converting the keynote into a website. Let me do one final verification pass of, it's crapping out. I've got my laptop over here crapping out, and I've got the service on the aux alpha crapping out. The only thing that didn't crap out was my Qwen implementation that was just hosted on my own local server. See, that just goes to show. If you can host it yourself, you can own your own reliability. That's a key thing. Let me see here. Since I closed this window, I'm going to open this window and give myself more light. A little bit more light. But the reason I closed that window is because it was shining onto the laptop. And I was like, if there's anything that's shining on the laptop, it's bad. Anything on the laptop is bad for now. I will be right back, though. I'm going to close this other window because it is it's breezing in. You would think that after 4 weeks of a month of this, I would have it all figured out, but still learning, still figuring things out. But that's cool. That's part of the fun. If I already knew everything, then this wouldn't be fun. I wish this wouldn't pop up every time. Thanks. I get that you're having downtime in 2 weeks. Gotcha. But I already acknowledged it. 1 p.m. test. Oh, it says the development is complete. Let me do a final verification pass of the current state before completing. I'll say once you're done, start it on port what did I say? 1258, 1259. I need to try it. I keep forgetting that I have this once you're done, start it on port 1259 for me to test and try out. Okay, well, the numbers don't work as well as I would have hoped. But yeah, I've got this new transcription software on here, and I keep forgetting that I can use that. I'm actually going to talk about the transcription software later because it's cool, it's fun. It was an agentic thing. I basically, yeah, I'll talk about it later. If this thing ever finds a way to inference. Since this thing says that it's done, I'm going to do say, please compare and contrast the 2 subdirectories in the current directory. They were both given the exact same task and the exact same instructions, and they did their own thing. They got to their own conclusions, and they marked their goal as complete. Please evaluate both of them against each other on the axes of completeness, correctness, elegance, simplicity, robustness, performance, output quality. Scratch that. Scratch that. Scratch that. Performance and output quality. Period. Then summarize and tell me which one you think is better overall across everything and with complete overall viewpoint. Something like that. Okay. Okay. Is this done yet? Ah. Another network error. See? Gotta own your own reliability, I think, on this stuff sometimes. But whatever. I'm just gonna start this. I'm impatient. It's had enough time anyway. And let's check in on our Keynote converter. View. Oh, it's outputting images. And it's viewing its own images. Okay, that's what it's doing. Yeah, okay. What Ox Alpha says, this says 2 projects made a genuinely different core choice. Qwen generates executable 3.js and visually judges rendered screenshots over multiple iterations. Ox Alpha generates a validated declarative scene graph and performs 1 text-based refinement. I'm now checking whether each architecture actually fulfills its claims, especially export support, failure recovery, safety boundaries. I will say that I was expecting what Ox Alpha did. I was expecting it to create and validate a scene graph. However, I was expecting it also to do what Qwen did and do the visual judgment and iterative improvement loop, rather than just like 1 single text-based refinement. So each one of them had aspects of what I was expecting. I'm actually not super mad at what Qwen did. I don't think I specified the problem in detail enough to make it not do that. And I think the fact that it had access to 3JS means that it was totally valid and viable to do that. And it gave it a benefit of, like, 3JS has a bunch of stuff you can use that might make it easier to get to the endpoint. Rather than like having to output your actual vertices, you can output primitives, you can use shaders, you can use some of the layout techniques that are available in 3J. Like, there's a bunch of knowledge also. It's also been trained more into the training data of the pre-train, I'm sure. So that's interesting. Like, there's a bunch of stuff that different choice that Qwen made makes it easier for Qwen. But Qwen also chose like a bad model. It chose some old Qwen3 coder model that isn't known for being a fantastic model. And then it used like some VL thing. So whereas Ox Alpha it picked Claude Code and Sonnet 4.5. And this doesn't seem to be able to even get to the next point. I really have to say, this has been my experience with this model so far, is like they came out with these big promises about all the tokens they can support, but I think like it's just not working out that great, for me at least. Like, I am impressed with what I see, with what it does, but I don't know if I can't really get it to fully finish projects. It seems to stall. This is interesting. This has been a good test. Ox Alpha is not doing as well as I would have expected. And it's not even doing as well as I've observed it to do in the past. Okay, Keynote Converter. I don't think it did. It said it opened it in my preferred browser, but I don't think it did. Whatever. Development, VOD demos, Keynote Converter, index. Cool. Wait, why is it so pixelated? While this goes, I'm going to go find this, add it to the dev stream for today. PG Rust. That happened right now. I responded to it. So I'll talk about it in a minute, I guess, once this is all done. I just don't accept laziness from these agents. It said these videos and several source graphs are high resolution, so those look sharp. A proper fix requires recreating the remaining slides as HTML/SVG or exporting full resolution slide images from Keynote. I should have flagged this limitation before calling it. I'm like, yep, do that. Okay. Oh, Ox Alpha finished. Let's try it real quick before I see the. Okay. This was Qwen. This is Ox Alpha. It's interesting how like mostly similar they are. They've got this like generate on the left. Wait, what's with this cozy wooden cabin thing? That's so interesting that it picked the same. I'm gonna pick the one from here though. Did it read the other directory? I hope not. But whatever. If it went up to the parent directory and found something in the sibling thing and went down and inspected it and whatever, I guess that's like context gathering. But I think it might have just like kind of, they might have just converged onto this idea. But anyway, okay, so let's try it. Generate 3D model. Planning the model structure. Generating. This usually takes 20 to 60 seconds. That's cool. It's got like a wireframe, turntable. I do like the UI of this a little better. Okay, draft accepted, 14 parts. A cozy little house with a red roof, white door, chimney, and a green grass patch. Critiquing and refining. And this is using Anthropic's SDK. It's using Sonnet 4.5. I think the model is probably better than the Qwen3 it was doing. Okay, interesting. That's an interesting. It's kind of cute. It turned out pretty similar, actually. Oh, crap. I wish I hadn't gotten rid of this. Well, I'll do it again. Oh, wait. Stop. You do 99 again. I'll say, yeah, 99. Why not? Okay, so this, 22 parts. And this did follow the plan that it said. It said it did one refinement loop. It does one generation and then one refinement. And I think that is what we saw. Now, I think this is a mistake. I think this meant to be half the size. I think these meant to be stopped up here. And I think this meant to be resting along the top here. And I think this meant to be down, like flush with the top of the house. So I think this could have used more refinement in terms of what it aimed for and what it got. Now, but it did a lot better job about placing, like, first of all, it didn't even have a sidewalk on the other one. And the door and the window are like better flush with the house than the other one was, than the Qwen model was. And the fact that it even has a door. The Qwen model didn't have a door. So a lot of that probably comes down to the model itself. But also, hey, whatever. It also could come down to the refinement loop. It could, we don't know. Like, I'm being output oriented on this one. It's on its third. Okay, 2, 3. It's cool. I like this. Actually, I take it back. When I said I like this better, I like this. How it shows me the hypothetical things, and then the critique. And then, oh, they put a little garden in there. And then the critique. Oh, whoa. And now they're doing round 4. I can't believe they gave this an 85. I guess from this angle it looks better. Here we go. Final result. Okay, so it got rid of all the grass and stuff, and it said, let's just simplify or whatever. Or something. And then, yeah, this one has a door, this one has a window, but it's not quite as nice as this door and this window. Like, these are more complex things. And this one has a path to the house, whereas this doesn't really have that. So I don't know how much of that comes down to the model or what, but I like what this did with this better. I like that it did the critique loop in a better way. I would say that these are, given the instructions and given what it had to start with, I would say these are roughly equal in quality. I would give this the edge. I would say this is like a 7 out of 10 from Qwen, and that this is like a 6 out of 10 from Ox Alpha. That's just my take. And Ox Alpha also had some real problems with, it finally got to goal complete. We finally got there. Okay, let's see what the judgment was from the model. My verdict: Qwen is the better implementation overall. Its architecture directly optimizes the central requirement: produce the closest looking 3D model by rendering candidates, visually evaluating them, iterating, and retaining the best results. Ox Alpha is simpler, faster in principle, safer, and more product-like, but its validation answers only "is this valid JSON geometry?" rather than "does this render correctly?" The matched run exposed that limitation clearly. It accepted a house whose roof was visibly exploded into floating slabs. That's exactly right. Wait, how did it know? How did it know? This must have saved it somewhere? Does it save? Test. Oh, it's like a test artifact. Okay, yep. That was the Qwen one. And then tests. I don't know. Maybe this ran its own test. Okay, completeness. Qwen is the winner. Correctness. Qwen is the winner. Elegance. Ox Alpha is the winner. I would agree. Like, this is a slightly nicer UI elegance thing. And I do kind of like the, like, I was expecting it to output the scene graph. Like, that feels a little bit more pure and elegant to me. Wait, where were we? Simplicity, Ox Alpha, yeah, it was just simpler. Robustness, tie, okay. Performance cost, Ox Alpha. Why? I don't know if I agree with that because it uses Claude, whereas the Qwen one uses cheaper Qwen ones. Output quality, Qwen. Goal weighted overall, Qwen. And it's not by a little bit. It's not just by a little bit. Where Qwen is stronger, the render critique revise loop is the best match for as best as you possibly can. You can use nearly the full 3.js geometry vocabulary rather than 8 predefined primitives. That's exactly what I said. It recovers from malformed code and render errors, imposes a worker timeout, and preserves the best successful candidate. Yeah. 3.js is vendored, so the application does not depend on a CDN at runtime. Its saved torus not result is materially more polished than either project's typical primitive assembly. Yeah. Where Ox Alpha is stronger, declarative JSON rather than arbitrary generated code. Yeah, I would prefer that, all things being equal. A shared deterministic scene builder. Yeah, that was what I was expecting. Screenshot, GLB export, wireframe, and turntable controls. Yeah, there's little polished things there. Usually only 2 LLM calls and no vision image upload. Now, I don't think that's a stronger feature. I think that's like a misunderstanding of the requirements, frankly. It should have done a vision image upload. That would have made it better. And more tool calls and more refinement would make it better. But it kind of just did this one-shot thing, or two-shot. One-shot generation, one-shot refinement. A constrained schema that is easier to store, edit, inspect, and secure. I agree. Like this and these, I do wish that the other one had done that. But the only 2 LLM calls and the vision image upload, that's debatable. However, the validator gives too much false confidence. I confirm that it accepts invisible models with a scale 0. Yeah, because it's not taking the screenshot. It just needed to do that. If the goal were a safe, efficient, exportable primitive scene editor, I would choose the Ox Alpha as the cleaner foundation. Okay, so I don't know. I think like this all has given me a lot to think about. I think my takeaway is that the inference for Ox Alpha is not good enough yet. You can't rely on it. Whoever their inference provider is not doing a good enough job. Because as soon as you get past some certain point, you just hit all these errors, and rather than compact and rather than just like being slow, it fails or it causes issues, and it's hard for it to get out of it. And you have to wait some time or manually push it forward or do something like that. I think what I have also noticed is that Ox Alpha is more succinct. It's more token efficient. It seems to do more with fewer tokens and use those tokens more effectively. Whereas Qwen, it does lots of tool calls. It does lots of thinking between tool calls. It's just a token furnace, but I think it's a relatively reliable token furnace. It gets you to the endpoint, and it might not be like the biggest frills. It might not have the most bells and whistles, but it's a pretty good workhorse model. Whereas this one, I feel like it's a little bit more questionable whether it's going to get there. But a lot of that is, again, inference. I don't know. It's hard to separate the inference from the performance of the model itself. Sometimes it's like, yeah, 1 and 2, 1 and it's like the same thing. I think Ox Alpha is an incredibly exciting model. I think all the speculation about who hosts it and who developed it and who hosts it, I think it's been fun and fascinating. I think I've had good but not great results with it in my own personal testing, and then also like this live testing. I am so curious about what it's going to be like when it releases for real, when we figure out who's behind it, and if it does turn out to be an open model, what's the difference going to be like when we can host it ourselves and we're not competing with everybody else trying it out at the same time? I'm so curious to try it. I'm so curious to learn more. It's been such a fun thing. Like this, I think a big part of it is just like the fun of speculating and the fun of this all. Of, hey, there's this new model and we all get access to it for free and it's beating Fable on a bunch of tests. Like, what the heck? But now it's down to reality. Now it's trying to use it. Now it's trying to actually get work done and seeing how good it is. And it is good, but it's maybe not as good as some of the initial tests made us think. And the real thing will be once we get it in our hands, and if it does become an open source model, what can we do with it? What can the open source community do with it? And what can we do with it locally? Yeah, so really exciting. Fun. This has been a fun one this week. I'm glad that we've got this going on. And I don't know. I hope they're really serious about zero data rate, because that's the one thing that makes me nervous. Like, all of this has been great fun, except for the question about who's inferencing it and what's their motivation. If their motivation is to tell everybody that it's zero data rate and then secretly keep it all and train it on it, or they're doing like the other thing I was thinking about is zeroth order optimization. That like there are techniques where just from serving a model, you can glean slight amounts of information about the model such that you can train from that, just from doing inference. You can collect all of that inference, or not collect it, but like you can I actually don't know how it works. I don't know how this all works, but I think there are techniques where you can improve your model and affect the weights just by running a bunch of inference. And so I was wondering if maybe it was something like that, some continual learning thing. But I don't know. Okay, let's see how this other thing went. Keynote Converter. Where are we? Okay, updated index. Where was it? Did I close it? Hey, cool, perfect. Oh, it even kept the video. Neat. Oh, this doesn't play. Oh, it does. Man, agents are so cool. I didn't have it. It came in Keynote, and I didn't have a Keynote. I'm on Linux right now. Like, there's no Keynote on Linux, so I was able to just like tell Codex, turn this into a website. That is so cool. That is freaking so cool. And there's like an overview. What is this? Keyboard shortcuts? Okay, but what I wanted to talk about this was this is this project PG Rust, and I went to this meetup, database meetup in San Francisco recently, where there were a bunch of different talks, and this talk was really, really cool. And it's just this idea of building one of the popular things that's starting to go around right now is this concept of a software factory. So it's like, how can we create software that reliably creates reliable software? And if you can move up that level, instead of creating the software ourselves, if we can move up a level and create the software that creates the software, then you have so much more leverage, because software, then you can generate software, you can tweak parameters, and then you get on the outside, when you run it through your process, you get the output is like different kinds of software or different implementations of that software. And what I find is this is one of the coolest stories about someone building, or like a team building a software factory kind of in public, in the open. And this is a very specific subset of a software factory. Like, I think there's a lot of companies that are like creating software factories internally, and there's a lot of companies that are creating generic software factories, or also there's, I think, a lot of ones that are creating like application focused software companies, where there's like these software factories for creating apps, or software factories for creating interactive visualizations, or software factories for creating games, or like, again, a lot of like corporate environments are starting to build these software factories internally, right? But this is a software factory. They're building a software factory for building databases, which I think is really cool, because there's a whole lot of existing stuff out there that you can take advantage of and map. And like, also, it's a really, really hard task. Like, one of the things that he was saying is that like our constraint on databases in the past has been like, we don't have enough great engineers that can be supported by enough money to build very many of these things. So you kind of end up in this place where, you know, we've got Postgres, which came around, I think, was it 40 to 30 years ago or something like that. We've got MySQL, and like every couple of, like maybe every decade or 5 years or something like that, a new database enters into like the fray. And maybe an old database falls out because it doesn't match today's workloads. But most of the time, you're kind of like starting from an existing database, you're patching it, and like the database grows to encompass the new tasks. But what if like we have these new things now? We have agents that can build software factories. So we can build more data. If we could build a database software factory, we can build more databases, and we can experiment with more ideas around databases, and we can tweak, like we can take papers that came out and incorporate them into the next version of the database and generate the next version of the database. And so what this was just a really cool presentation. I'm going to quickly go through it because I just thought it was neat, and it's a good case study in just these software factories, but it's also a good case study in data. Oh, the other thing that's cool about databases is that they have huge test suites and existing implementations. So if you get your software, like a great way to bootstrap a software factory like this is to try and match an existing target. So yeah, that's what they were saying, building a database factory. And blah, blah, blah. So so their whole thing was like, we're going to use our software factory to re-implement Postgres. And they have 2 people, and they did it over 4 months. And this is kind of like a cool and crazy project. So they analyzed it, and they sort of figured out, where are the ways that Postgres fails? It's either like in the connections, it's you get too much data in there too fast, and then you have like a vacuum problem where it's hard to catch up on the vacuuming. Your plans can go awry, where you've either got really poorly performing database plan or query plans, or like a one-off query plan that doesn't go right, where it like kicks out your normal workloads, and your normal workloads are now waiting behind like something that's really inefficient, or JSON. I don't know what he was saying about JSON. I forgot, but. Yeah, this is like some of his background. So they went. This is like the talk is like, why? How did they build a factory? How do they verify its output? And then like they claimed that they got a 300x performance improvement over the default. So where did that come from? And so he went through and he said like the first time they implemented this, they basically just gave it a goal, and they said re-implement against the test suite. They had the test suite, the Postgres test suite, and using that, they could theoretically, you could just say, hey, agent, go use this test suite as a test, and then build the exact same thing, but with our own implementation so that it passed these tests. And basically what he said was that it worked, but it was difficult because the tests were not complete. The tests were good and they were relatively good coverage, but like the tests did not cover every single aspect of Postgres. And so they would do these things where they would find that all the tests would pass, everything would say it's 100% working, but it wasn't actually. But like they would find all these weird bugs in production, and there was this kind of this unsatisfying long tail of bugs that came from just like not looking at the source code, from it being a black box, from the tests being somewhat incomplete, and that just led to like an uncertainty in the product where, like it's like, have we actually smashed all the bugs? Have we gotten everything figured out? And so this was like a good first prototype where they kind of figured out that it was possible, but it didn't work out great because they didn't end up with a bunch of confidence in the final product. So the second time so this is this concept of the software factory where like you try it, you put in place your software factory, you put in place the parameters. In this case, it was like target the API, target the tests, and make it pass, make all the tests pass, make no mistakes. The second version was they were saying, look, we don't need to be completely black box. We can actually take the internals, we can mechanically translate them using a non-AI thing, and then potentially like clean it up. So the second attempt was they took this offline, this like old school non-agentic manual translation software that took C and turned it into Rust, but it turned it into ugly Rust. And then the idea was that they wanted to clean up that ugly Rust and turn it into robust Rust. But the problem was that he said with this version was that it was so bad, like the Rust wasn't just ugly. It was like fundamentally wrong. Like the way you do access patterns in C and the way you write your stuff in C where everything is a pointer, there are technically equivalents to that in Rust. And if you use those equivalents, then you're using like the C-based access type patterns, but in Rust, right? But to change from those types of patterns to the real Rust patterns was like actually a huge lift. It ends up being a complete rewrite, because what he was saying is that like the way that the Rust borrow checker works is that like it all has to kind of solve and be complete. So if you start to like take one part and make it not use these mutable pointers, it kind of spiders out, and you have to make all of the calling things. Everything that calls it has to change all of its call sites, and then if you change it, like it chains out, so that basically it ends up being this full rewrite where you kind of haven't gained anything from doing the mechanically translated part. You end up having to rewrite the whole thing anyway, so it ends up in kind of a similar boat where you have to rewrite the whole thing. And then he said the third thing they tried was saying, okay, we're just going to go file by file by file. We're going to say each file gets like, and they put in place rules that said like what the translations should look like for file by file by file, and they got really strong rules. The problem was, since it wasn't done like with a global understanding, each single file made different choices about how it like there's choices about how you make these translations. Where's the link? The link is right here. Oh wait, crap. I'm on a different computer. I'll send the link in chat real quick. If I can. Yeah, I don't know about the August 2 thing. I downloaded the keynote and had Codex rewrite it into a website so I could browse it on my Linux box. But anyway, he was saying that like, okay, their third attempt went file by file by file, but each file, the stream title says O2. Oh, I guess I forgot to update my stream. I don't know. I don't know. But yeah, so each file, when you did the translation file by file, there's all these choices you can make about what happens when you translate a pointer into Rust, and it each file made a thing that makes sense for itself, but globally it didn't follow the same rules. And then you would have these like three different ways. For example, like sometimes it would translate into a reference. Sometimes it would translate into a usize, which was like a pointer into an array of something. And sometimes it would translate into like a Postgres OID type that it had created, which makes sense for some things. And it just ended up being this problem where they had, when they got to the end of the project, like there were just way too many mismatches on a file by file basis. And so this didn't work either. And sorry, it wasn't even file by file. They did crate by crate basis. Sorry. So it was even bigger units than files. It was like at the level of each crate, which kind of makes sense. And you would think it would do well, but it just didn't. And so he said like the fourth thing they tried finally worked, which was they did do the regression tests, but wait, what did he say? Anyway, I forget what this one was. I think what he said is they did it in a clustered way. Oh yeah. This is what he said. He said they did it in a clustered way where they would do like one crate and then they would do the crate that like attaches to that. Like they did things not so separately, but like in a 1-to-1-to-1 way where like it was growing from a core and then growing out from there and creating like a bigger and bigger software project until it was complete. And then he said the fifth thing that they tried. So this is what I'm talking about the software factory being so cool, is because like you can tweak the method and then you get a completely different software output on the other side. And so it's like figuring out what the right way to create the software automatically is really, really valuable. And every time they go through one of these things, they're becoming smarter about Postgres and they're becoming smarter about how to do the software factory thing. Like they're learning more about like the internals of Postgres and like databases in general and performance and all of that, as well as Rust, as well as like what does it take to make a software factory that does this in like the most reliable way and output something that again isn't just like 8 times slower. And so their fifth thing that they did was they basically said that they did the similar thing that they did the fourth time, where they started with a cluster, created a core, and expanded on that core until it got to the full thing. But this time they made each single thing either match or beat the performance of a micro benchmark compared to the actual Postgres implementation. So like they gave it a Kubernetes cluster and they gave it the ability to write its own little micro benchmarks and test it there, and then they wouldn't merge it into each subsequent code piece into the repo until it passed some micro benchmark that it had, and it either matched or beat the Postgres implementation. And so this meant that like it never needed to be a full rewrite later. It never needed this like stop the world and rewrite everything, or like they didn't have anything to make up for. Like it was maintaining performance the entire time. But then he talked about how like it's not, like I said before, Postgres only has 67% of code coverage. So passing all the unit tests and all of the integration tests and everything doesn't mean, it means you're like 67% of the way there, but it doesn't mean you're done. And so they basically just found this is what it takes now to like build a validation layer of a software factory about databases. Is you have to do things like buzzing, where you're generating random data based on like the protocol itself and sending it through both and making sure that either both don't crash or that they perform the exact same way or they output the same thing. And then he was saying that like they found a bunch of bugs in Postgres that they're reporting through this method. And then they found that there's different methods. Like there's fuzzing, there's this Kenny thing. I don't really know what that is. He said they're working with it. And then simulator, like this last one he said was something like a Jepsen style simulator where you can like simulate crashes at various different points. And like, yes, this makes total sense to have this as part of a software factory. So then now that they have like the base, they figured out like how to do the factory and create like Postgres, right? Pretty much. It's not perfect. They still have more to do, I'm sure. But like once you have this, you can start to do things that like would be incredibly hard to do in regular Postgres, like using the sea of like contributing to the sea of Postgres. It would take a lot of manpower and or just a lot of time, or it would take too many different experimentation things until you got to the right, or it would be a big rewrite of some type. So like there's a bunch of things that they got to now try because they've got it building, because they built it in the software factory thing. And this is where I think it gets really interesting, which is that they can try higher level things. Like what he was saying was that they have, there's this research lab out of Germany that they keep on putting out these like cutting edge ideas in research papers that they've validated at small scale. And he was saying that they could just plug those papers into their software factory and try out the ideas at Postgres scale and try them out, including all these like different validation things that they've got going on. So that's pretty cool. And so this is like the things that they said they've been trying and gotten to work, which is they're using SIMD and they're using batching, and they're able to basically do things in a much more parallel, or in a more batched way, where they're operating on, they're chunking, or they're separating and then operating each separated piece on a batch and then merging it at the end, kind of like a little bit of a MapReduce type thing. The sum at the end, and then the separate sequential scans, and then all of that being SIMD. Makes sense, SIMD. And then they said they also they were able to build in a columnar data format, where if you've ever used like a Vertica or a Cassandra, or there's a bunch of these like column-based stores, where it's a lot faster if you don't have to, if you're only doing a sum, for example, you don't have to like read all the data for each row just to grab one column out of it. You can like, so they have a way of, I don't know if it's an automatic columnar format where it like determines how to store things dynamically. I don't think so. I think they've probably modified it, but like you can imagine how being able to insert a columnar data format in Postgres would make it faster. And then he was also saying they were able to do things like, there's a lot of things like timestamps, for example, where a timestamp, you know, there's a base number that you're just always going to have. Like if it's an epoch offset or something like that, like you're just going to start from some base that there's a lowest value. They found that they were able to just like have the bits by most of their data. Like a lot of times your actual data fits within a pretty small range that could fit in within a 16-bit number. And so whether it's an integer or a float, like you can save a base and then an offset from that base in 16 bits, which allows them to just basically drop things in half, which affects things like scan speed and performance all over the place. And then they were able to do things like, okay, they created this dictionary of common words and common strings, and they were able to turn that into like basically a lookup table where there's just small integers that represent that thing. And then what he was saying was that, I don't know if there's a slide about this, but he was saying that there's actually a bunch of queries and things that you can operate on without ever like doing the lookup. You don't actually have to go back to the word if you're doing like a count of different number of things. So there's things in their query plan that they can do that literally never need to go and look up this thing in the table. Blah blah blah. And then this is the big one, right? Like Postgres is a pre-forking server-based architecture, right? Like it doesn't do threads in regular Postgres, and that's like one of the biggest reasons why people are always doing things like PG Bouncer and stuff like that, so that they're not so they don't have like some client that's opening a connection to some server and just holding it open and not doing much with it. Like you have to do a bunch of workarounds with normal Postgres to make this efficient and make it fast. Whereas what they were able to do was like take the same thing and take the same contract and all the same fuzzing, and behind the scenes build a threaded executor model where they're doing like a work stealing thing. And I wonder, yeah, this is where they're talking about. So yeah, instead of having it be a process, where the process to go from one process to the other, you have to serialize it, send it over some bus, or push it over shared memory, deserialize it on the other side. That's like a bunch of work that you have to do. Whereas if you've got a threaded model, you can just share the access to the data, and you don't necessarily have to do all that serialization and deserialization. That just saves a bunch of stuff that you just don't even have to do. And then beyond that, they found that, like, this is the part that I don't really know. I actually asked for this slide because I wanted to look at this more, because I don't know 100% what this means. I'd like to look more about this. But they have this like shared queue and like this work stealing mechanism where there's a thread pool that's pulling quote unquote morsels, which I guess are these like small executable chunks of progress that it makes towards a query plan. And so that it takes a query plan, chunks it up into these quote unquote morsels, and then the morsels get work stolen from the queue and then executed in this like wide thread pool, which is like much more efficient than the process based one. So blah blah blah. What is this? Oh yeah, this was another optimization they did where they were able to like basically do a map reduce type of a thing, where instead of something that had to be sequential before, they can like split it up, have multiple things working in different threads, and then combine at the end. But yeah, so like I just think this is really cool because this is exactly the type of thing that like the software factory stuff seems kind of like eye-rolly up until like to match Postgres and to like recreate some database software from agents. It's kind of an eye roll, right? But once you get into this, like, okay, now we can try all these new things. We can like take papers, and specifically he was saying that this morsel stuff was another one of the papers from that German research lab where they just plugged it in and they were able to get it working. And like so I think this is a really cool example of how the software factory can like create opportunities for massive improvements over what we have today. And that if we can get it working like they have, then we can start working on like the really next level, high level stuff. And you can imagine how once they've got this working, it doesn't need to be Postgres anymore. Like they could generate more databases that are different than Postgres, that are tuned for specific applications, or versions of Postgres that are tuned for other downstream applications as well. So yeah, I don't know. I'm glad that he responded with this keynote. I'm glad I was able to convert it because this was I guess I just kind of reproduced the talk a little bit. I'm sure it was recorded. You could probably go and look at the original, but I don't know. This is my take on it. I guess this was like a reaction to the slides. So that was pretty cool. I just think like software factories are lame until they're awesome is kind of my takeaway from this. It's like matching Postgres, who cares? Postgres to Rust, who cares? But like a reproducible factory where you can plug different things in and try different experiments and hill climb to get to 300 times faster, that's really cool to me. And still have confidence that like your fuzzing is not only matching existing Postgres, but also you're like finding bugs and reporting them in Postgres. That's cool. So yeah, software factories are cool. It's kind of a cool new world. So what should we talk about next? Talked about the last stream. We talked about the Marin training run, which is super cool. We did the Ox Alpha stuff. Oh yeah, Muse Spark came out. We should talk about Muse Spark came out this week. I actually haven't looked at all these details. Last week I used Muse Spark 1.1 quite a bit. One thing I gotta say is that, where is it? I'm gonna close all the things to the right. Muse Spark 1.1. Let's see, where are we? What is Meta's like their hub thing? That's what I'm looking for. AI. Come on. I want like the dashboard. Come on. Is it dev.meta.ai? Here we go. That was way harder to find than I hoped. Okay, so there is this Oops. Oops. I'm leaking. Models. Here we go. Okay. So last week I was playing around with Muse Spark 1.1, but one of the big reasons why I was doing that was because if you go to their contributor model, like look how cheap this. Here, wait. I think I need to. So if you use Muse Spark 1.2, it's like, or 1. This 1.1 and 1.2 have the same pricing and everything. It's just a further post train. So like 1.2, it's actually a pretty good price on this. Like if you look at the level of capability of the model, and then you also look at like what you spend, it's a pretty good ratio. Like it kind of matches with the old pricing of like the Flash model on Google. I think it's been surpassed a little bit. Oh, I don't know. You said how somebody asked how much did this Postgres port cost? I don't know. That's not me. I didn't do it. But they were saying that they used Fable for like the entire 5th iteration or something like that. I don't know. I don't know what that was. I think they, and who knows what they're doing, right? Like they're 2 people. It's just 2 people. It's not like a big company behind them. So they could be like pooling 10 subscriptions to that, to like Claude Code, and just switching between their 10 subscriptions or something like that, and using and finding ways to be token cheap that way. Or maybe they've got like investors or something. I really just don't know. Is Fable God tier at Rust? I don't know. I don't. Fable is a tough one because it is so expensive that I've only gotten so much time with it. Like I use whatever Fable I get with my subscription, and then it's out for the week. It's usually like gone in a day. I have generated Rust with it. It's pretty good at Rust. It actually is pretty good from my experience. But I don't know if it's like better at Rust than other things. I feel like Soul might be a little bit better at Rust. GPT 5.6 Soul. I think it, for whatever reason, it's like a little bit more mathematical and a little bit better at instruction following. Fable is more creative and better at like security things and like visual types of outputs, I find. Can't get it to read 20-year-old font shaping system at work. That sucks. Yeah, I don't know. Maybe Fable 2 or whatever will be able to, Fable 6 will be able to read it. But you should give this a try because, well, this is what I was going to say. So I was playing around with Muse Spark 1.1, and it's not bad. It's not a great model, but it's also not bad either. I would say it's similar to like 1.1 at least was similar to GPT 5.6 Luna at X high. It felt like to me like about the same type of power. But if you are willing to let them look at your logs, then they're willing to drop the price by a ridiculous amount for 10 cents per every million tokens in and 0.0002 for every million token out. And it's got 1 million tokens of context. Cached input, 0.002 cached input. And so when you look at the pricing there, like you don't want to use this on your, well, I did it on a bunch of stuff. A bunch of like projects that I don't care about. They're new projects or things that I was messing around with or whatever. Like, I don't care. But I learned a lot about the model based on that, and also was able to iterate on those projects a lot without really spending much on it. So that's pretty cool. But yeah, there's a reason why they don't just switch everyone over to 1.2 contributor, and that they offer this version where they're not looking at your code and they're not looking at your trajectories. But also, like, another thing that I was thinking about when I was doing this last week is that like by using the contributor stuff, I'm potentially making them better at my use cases that I care, like the things I care about. So I don't know. It's a trade. It's worth for them. This is what I was thinking about the other day. When is this going to flip, where they start to pay you? Because at some point the trajectories are more useful for them than, and the long tail of the things that people are doing with it are more useful to them for improving their model than you paying them for some like, I guess like marginal version of it. They need real engineers to design chips to run models and reduce costs. Yeah, I mean, that's the idea, is that eventually they're going to use their models to design chips, and then there's supposed to be some like recursive improvement loop that happens that we'll see if it ever happens. But yeah, but let's look at like, I know that they released a 1.2 this week, so I did a lot of experimentation with 1.1, and it was pretty, like I said, pretty good. But 1.2 came out this week, and I want to read a little bit about what did it change? What is better about it? So what does this say? Okay, this month we launched Muse Spark 1.2, a coding-focused update. Our earlier demo showed some of these capabilities in action. I don't care about the demo. 1.2, it looks worse on reasoning. 1.2, it's a little better on simple VQA. So it's visual question answering. It's a little bit better. I don't know what zero bench is. What's zero bench? Visual benchmark. So another visual benchmark. What is it? Why is it called zero? Zero bench. Okay, the top model is 5.6 Sol. I want to see like an example of zero bench. Project page. Oh no, that's where we were. Poster. Here we go. Okay. So zero bench. Visual benchmarks saturate quickly. LLMs exhibit shortfalls when interpreting images, and by some measures have poorer spatial cognition than young children or animals. Yeah, sometimes they make the worst calls on these visual things. Zero bench was designed for longevity. Benchmark curation, question creators, candidate questions, adversarial filtering. So when models got it right, they fail it. Only when models got it wrong do they pass it through. Okay. Okay, so they're doing things like giving it musical notes and saying, what are the notes pointed to by the pink and green arrows respectively? Okay, it's good to know. So the top model, like I wish I could scroll easier. 78%. Oh, okay, so this is saying that, like, hey, we've got this Arc AGI, which was designed to be difficult for LLMs, but they're climbing it very well. And when you look at zero bench, which is like this visual question answering thing, like it's been slower. Okay, so it's a good benchmark. Okay. And they're saying that they improved by quite a bit on it. That's impressive. Muse Spark 1.2's multimodal gains are most pronounced when the model can use tools. It can inspect visual inputs more closely and incorporate what it finds into its reasoning. So without tools, it's actually worse. That's interesting. It's worse without tools, but it's better with them. Multimodal capabilities. Muse Spark 1.2 supports a broad range of multimodal tasks, from turning visuals into working code. You know what? Let's do this. We did this benchmark with Qwen versus Ox Alpha. I'm going to say, first of all, I'm going to update my extensions. I'm going to use Flash, and I'm going to say, okay, update my Muse, scratch that, Muse model in Pi agent models. This is not a good one for me to use text-to-speech on. In Pi agent models.json to swap 1.1 for 1.2 in all cases. I'm going to swap out 1.1 for 1.2, and then I'm going to run the same test that we did on Qwen and Ox Alpha. Muse Spark, or I'll say, 1.2. What was it? Initial instructions. And then what was my initial, let's see what my initial, here we go. My goal was read initial instructions, and continue development until your confidence complete. Okay, we'll do the same thing. Okay, so this is Muse Spark 1.2. And I'm going to use the contributor model because, like I said, I don't care about this code. They can read anything they want from it. Oops. And so let's paste. Also, let's see. Anyway, let's just have it go. Let's see what this does. So we tried Qwen, we tried Ox Alpha, and now we'll try Muse Spark 1.2. And it's a lot faster, actually. That's pretty impressive. They might be working on their inference performance as well. Wait, it's reading the other. No. Okay, that's not cool. Oh, wait, I forgot. I know why, because I didn't go into Muse Spark. Okay, that's a little more fair. Someone asked, am I Viber coder? I'm a coder that also sometimes vibe code. Yeah, I guess we're all vibe. I'm vibe coder now, sure. But I've been coding for 20 years, something like that. So I definitely haven't always vibe coded. But these days, like, I don't know. I don't always read the code that comes out. But okay, yeah, I'm impressed with at least the inference speed. So while I let this go, I'm going to read about the new model. Because like I say, I did a lot of playing around with 1.1 and I was pretty impressed with it. But like, I don't know, compared to like the local Qwen 3.8 27B, it wasn't that much of an improvement. But let's see what the new one looks like. Okay, so this says multimodal capabilities. It seems like they focused mostly on visual question answering capabilities, but let's see what else they did. It's visual coding. Muse Spark 1.2 creates digital artifacts such as web pages and games, where correctness is judged by whether the result renders and behaves as intended. So that's actually a perfect use case for this test. Where remember we created a like this 3D modeler idea where you type in something, what you want it to 3D model, it generates a version, it renders it out, it reads the render, it generates an updated version, it reads that render up to n times, and then, yeah. So that's the idea. Let's see, and so that means that Muse Spark is going to be good for that. Given an image or video, the model must translate its layout, hierarchy, and style into working code. By re-examining the artifacts it generates, it drives a continuous self-improvement loop. What is this? Oh, it did a Godot engine game. Okay, well, I'm on Firefox in Linux, so I don't really expect it to work. Here we go. And this is just like this little mini website it created. Okay, whatever. The model shows strengths in converting images or videos for web development as shown on Design Arena. Model inclusion and rankings as of August 18th. So Kimi K3 still has the top spot on Design Arena. Design Arena is pretty great. I don't know what they did with K3. Actually, I thought Opus 5 was the top of Design Arena right now. Oh. No. For some reason, I thought Opus 5 leaped it. But yeah, K3, they did a great job with that model on design. But it looks like Muse Spark is getting better. Although not that, it's like almost like there's this weird plateau right there. But yeah, video to website seems like something they've specifically trained. Image to front end, that's what they were showing here. Why don't they show Muse Spark 1.1 on that? Robotics. Spatial intelligence bridges the gap between digital perception and physical action. A specialized variant of Muse Spark. Oh, I don't care about that. It's some specialized thing. Audio-visual understanding. Muse Spark 1.2 combines deep video understanding and dense captioning with a powerful suite of... Okay, that is... I'm curious about their video captioning.
Let's see what I have. Not fresh. Okay, let's see what I have. Okay. Fancy.
Transcript is pretty good.
All right.
The
Not
descriptive
fresh.
updates are pretty good too. This is pretty
How
good.
about this side? Plenty of this for the baby.
Bosch
Let's
French door
see.
refrigerator. Knew the brand. White dry
This
erase
is
boards with
interesting.
handwritten red text. Didn't we see that?
And then, what is this? Okay. And that.
Dog needs. Yeah, wow, right at the beginning. Okay, so that's showing, it's not showing specifically what we're seeing on that specific frame. This is like, this must have been something they did in the post process, like the after the fact.
Okay, let's see what I have. Okay, let's see what I have. What is this?
The brand, the fact that they've trained the brands in is pretty interesting. Shows you what they care about.
Okay. And that. How about this? Oh, it's not fresh. This. How about this? Oh,
Okay, good enough.
it's not
But
fresh
I don't even know
anymore.
if the previous model did video understanding. So that's kind of interesting.
This would be
I actually don't even know if it had an
perfect.
adapter for video.
And this for an
Maybe that's why they didn't show. No, they had definitely had image. So they had it before. They had video adapter. Audio visual understanding. Muse. Oh no, that was before. Wild artifact bench, measuring utility in real world agentic tasks. By the way, let's check in. This is. Oh no, goal complete. That was fast. Run it on port. Wait, this was port 1258, 1259, 1260. Okay. Okay, let's see what this does here. Also, no API key set. Open settings. I don't. Oops. I'm currently on a live stream right now, and I don't want to leak my API key. So can you look up the API key that's in my environment and then add it to the demo programmatically, please? See if it does, if it can do that. And again, I'm using Muse Spark 1.2 to do that API key thing. It's funny that it chose OpenAI as its model provider. Like Qwen chose Qwen. Ox Alpha chose Claude, and now Muse Spark is picking OpenAI. So I don't know why these things make the choices they do. Usually, like they pick themselves, but I guess not. Okay, just restart. Okay, let's see. Hey, stream safe proxy active, and I'm going to use that same cozy house that I did before. Oh, this is nice. This is a lot nicer. This is a lot nicer than either the Qwen or the Ox Alpha stuff. Like, by far. By far. Oh, GPT-4o, though. It's going to use GPT-4o. Okay. Honestly, that was pretty fast, too. But it didn't do the iteration. It did agent, okay, drafting, render, done. It didn't do any, okay, both of the other ones, both the Qwen one and the Ox Alpha one, both followed the instructions and added a refinement loop to make it better and better. So that's interesting. This one didn't do that, but it did a much better job at creating this website. This is a much better website. And also, like, this was a pretty good one-shot just from GPT-4o. So that's interesting. Actually, let's go back. Now compare. So I used Codex to compare these two things. Now compare the both with the implementation of, was it Muse? What was it? Muse Spark 1.2. So we'll see what Codex thinks about, like, I know what I think now based on trying it out. I'm curious what Codex, their conclusion will be. Okay, back to, so this is interesting. This is a great real world use case, because what I was totally expecting it to do was put in place one of those loops where it generates a screenshot, reads the screenshot, which is specifically what Muse Spark 1.2 is purportedly trained to do. But it didn't do that. Like they were talking about the loop right here. Where was it? Right here. Where correctness is judged by the whether result renders and behaves as intended. Given an image or video, the model must translate its layout, blah, blah, blah. By re-examining the artifact it generates, it drives it. That's exactly what I wanted that to do, and it didn't. That's interesting. I might have needed to nudge it towards that or something like that. But okay, wild artifact bench, measuring utility in real-world agentic tasks. We talked about. We started reading this. Making production-level games. We want the ability to evaluate an agent's capability across a wide spectrum of multimodal tasks. Oh, this is an internal evaluation. Wild artifact bench used to evaluate agents on any task. So current industry. So they're saying that they think they have a better benchmark than the industry, which is something that's more of a competition rather than using a rubric. So rather than saying like score along this rubric and then whichever scores higher, this seems like this is like a comparison thing where you're saying look at two things or look at three things and score them, which one's better. That's interesting. Scope of tasks includes almost any task and format regardless of verifiability or subjectivity. That makes sense if it's a competition-based thing. Whereas a rubric-based standard industry benchmark, you're going to have like a verified answer, or you're going to have like a golden data set where there's like a proven known good result that you're trying to aim towards. And if you're aiming for superhuman, then you can't use one of these because it has to be generated by humans. So if you're doing some sort of comparison based or heads up competitive benchmark, then you can kind of just keep comparing things, although you eventually have to calibrate. Practical real-world tasks versus specific vertical tasks. Yeah, if they're saying like generate a production-level game, that's a pretty big task. And that's not really a synthetic, that's not really like a small vertical task. Okay, win rate and ELO scores are obtained by comparing the deliverables of the tested and baseline agents. Okay, that's what I was saying. Both agentic judges and human judges can do the comparison and choose a preference. Yeah, so that's what they must be doing. They're having agents compare, agents do a bunch of work, and then they have humans that judge the judgments, and they're calibrating their agent judges to make it more and more aligned with the humans, and then hill climb that. Okay, what does this say? Cost-wise, Opus 5 isn't doing so great, but score-wise, it's doing great. Muse Spark, they're trying to show this in a good light. They're saying at least it's cheap. At least it's cheap, which is true. And that's not even counting their contributor cost basis. As a preview, we're releasing 10 tasks from Wild Artifact Bench. That's cool. This is a step forward in our ability to measure the real practical utility delivered by multimodal agents. Okay. So there's like a driving trainer, ultrasound analysis, create an in-browser reinforcement learning demo with 8 parallel 3D drive. Oh, cool. Wait, so where are the 10 tasks? Oh, they're over here. Okay. Video editing. Very relevant to my interests lately. Big Buck Bunny. Are you kidding me? Plywood Whale, digital design. Inspect the task files, instructions, source material, and evaluation criteria. So there is a rubric, but the rubric is part of one. It seems like this is like part of one of these heads-up designs. Okay, microchip model. Instruction, build a 3D model of the microchip describing data. So okay, they released some tasks. That's cool. The future of Muse Spark at Meta. It's used for media generation, use image and video, translations. I do think, honestly, Meta has a huge advantage here with all of their videos. Everybody else is trying to scrape YouTube and getting caught for it and getting or having to do licensing. Google and Meta have huge advantages here by just having either YouTube or Instagram and Facebook. And the fact that they have all that is such a benefit for them to create these like video understanding models. They just have so much more long tail data. Even though like it's very expensive to train on, it's very impressive. Or it's a very big, I guess, like differentiating factor in what they've got. Okay, let's see what this thinks about Muse Spark. Qwen remains the best overall implementation. Muse Spark ranks second now, and Ox Alpha third, for the specific goal of producing the best. What is going on with this? It's like rendering in a really weird way. What is going on? Okay, Qwen, best overall. Muse Spark 1.2, best UI and fastest experience. I agree. It did have a great UI compared to the others. Ox Alpha, best safe data model foundation. Yeah, okay, I agree with that. No visual quality loop. I agree. That was a big miss. The claimed sandbox is not a sandbox. DOM injection. I don't care about that. Production preview is broken by default. That's fine. Production, I didn't ask for production. But it is interesting that it didn't production harden, whereas the others might have done a little better. No automated tests. Well, what was the top thing? It was like doing a weird... Oh, it looked at all the outputs and compared the actual results. Where Muse Spark is excellent. Muse has the best user-facing application of the three. Polished, responsive interface, yes. Correct automatic model center. Okay, this is all about... See, this is not... It did it again, where it said a good thing was that it only did one LLM call. But I don't actually think that's a good thing. I wanted it to do an agentic loop where it did more. Provider configuration and offline heuristic demo mode. The production bundle builds successfully. Weaknesses. Does not render preview images. Yeah, one thing I really like about the Qwen one is how it like showed all the iterations and you saw the screenshots rendered out and you got to compare them yourself and you saw it as it was progressing. Whereas none of the other ones did that. It does not compare multiple candidates, bad. Improve proportions or missing details, or reject an empty model. Another one that didn't reject an empty model. That's two that don't reject empty models. That's so bad. Like, it's basics. So honestly, the Qwen one, Qwen 27B is a very impressive model, 3.8. Okay, this is Muse Spark 1.2. I think they're just going to keep hill climbing. I'm excited to keep like reading these updates. I'm glad that they continue to have this contributor pricing because it's just so good. And also their inference speed is actually quite good. So that's nice. I mean, it's Meta. They've got a bunch of GPUs, but it's nice to see them putting them towards this. Cool. Okay, wait, where was I here? Oh yeah. I'm not going to do the same thing for Gemini 3.7 Flash. It's just important to note that Gemini 3.7 Flash also released recently. I was going to go through it, but like I don't really want to. I don't really care enough. And every time I try the Geminis, they just suck. They just suck. But it's nice to know that like they're trying to aim towards the Pareto frontier. They're trying to push that cost down and keep the intelligence level pretty high. Arc AGI 2 is like becoming less and less of a, I guess, like an indicator of a benchmark, but it is still directionally pretty interesting. It's interesting that like Sundar Pichai is tweeting about this. Like they are really trying to put it out there, it seems, for Gemini 3.7. Well, let's try it. Let's do it. I want to do it. VOD something. 3D modeler. Let's make a directory for Gemini 3.7 Flash. Gemini is still one of the best for OCR and analyzing images, though. Yeah, that's true. Multimodal. I was saying Muse. I was saying Google and Facebook both have, or Meta Google and Meta both have like these incredible data sets for doing their training on those models, and it's hard for everybody else to compete with the multimodality of those. So yeah, but let's see. I'm going to take the Muse Spark initial instructions, copy it here. I have to do update my agent models.json to include and use my Gemini API key. That's unless I'm going to open another Pi and see if it's already there. I guess I could just go through. Oh. Hey, okay, I don't even need to because never mind. Stop. Okay, I'm on Gemini Flash. What are the different? Okay, I'm going to put it on high. I'm going to give it the same goal that I gave this one. Oops. See how it does. I will be very curious. So we've done 4 now, or we will have done 4. Muse Spark, Ox Alpha, Qwen, and now Gemini 3.7 Flash. We shall see. I wonder what model it's going to choose. Ox Alpha chose GPT-4o. Qwen chose some weird Qwen. Wait, what did it choose again? It chose Qwen3 Coder 480B. It's kind of old now, and it chose this Qwen3BL through Deep Infra. It noticed that I had a Deep Infra key, and it chose that one for some reason. And then this one, let's see. So Ox Alpha chose GPT-4o. Qwen chose Qwen. Muse Spark chose, or no, Ox Alpha chose Sonnet 4.5. I forgot. Sonnet 4.5. That tells us a little bit about when it was created. Sonnet 4.5, it means the pre-train is probably like from beginning of the year, from December, January era. Tells us a little something about Ox Alpha. Whoa, look at all that Gemini 3.7 Flash generated already. It is a pretty fast model. I have to give it that. Okay. While that's going. Oh yeah. Okay, I haven't tried this yet, but this is awesome. This is like anytime. Okay, I've been doing a bunch of I've been doing a project where I have to submit these big blobs of data and have it describe those blobs of data. In fact, it's audio clips, and I'm submitting the audio clips and saying like describe these audio clips in text, right? And I tested against Inkling, the new Thinking Machines Labs model, and then I realized that Gemma 4.12b actually has an audio encoder as well, an audio input as well. And so I was even just using Gemini 12b because it's a lot smaller and I could like boot it up. But like one of the big things that I was realizing was that, so in doing that, both of those models don't have great inference providers that allow you to submit audio. So I had to like use RunPod to spin up my own version of those things using either VLLM or SGLang. And it was so painful that like anytime I had a new batch that I wanted to, you can't leave it running, because if you leave it running, you're just wasting money, right? And so I did this thing where like I would have it spin up on demand and load up the model and then compute my stuff and then shut down, right? And that was the way I was able to maximize my throughput and minimize the amount I'm spending and all of that. But one of the things that was just killing me is that I would watch as the model, as like the Docker container booted quickly, got into like everything was already pre-installed properly, but like just the act of booting up the service took so much time that like it would take more time to load all the weights up and validate and run the compute graphs through it and optimize than it took to actually do the batch inference, which was just like, it's painful. And so when I saw I just saw this today on social media, this idea of being, or for at least one inference provider or one inference stack, that they're finding ways to make that part so much faster by taking it and making it a zero copy operation. So whatever it is that they're, I don't know exactly, let's actually read this. Today we're introducing, wait, let's see. Today we're introducing weight cache daemon for SGLang. On Ling 261T FP8, it reduced weight loading to less than a second. From 405 seconds down to less than a second. That's insane. And cut total engine startup from 8.8 minutes to 0.53 minutes. So we're talking basically 31 seconds, I guess, 32 seconds. Here's how it works. What made cold start so slow? Weight loading dominated the startup path. Each tensor parallelism rank had to read around 120 gigabytes from disk, deserialize it, that makes sense, apply tensor parallelism sharding, that makes sense, run FP8 quantization, and repack the weights. Every restart repeated the same deterministic work. That's true. And some of that is nice because some of that means that you can control, like you can have the weights be a higher, like be BF16, but then serve it in FP8 quant, and you don't necessarily have, like, it's nice to be able to do that in a configuration rather than having to do an entirely separate model export for that. But it does seem like a lot of this you could just reuse. The solution is a persistent GPU process that keeps transformed weights ready for reuse. One daemon runs per GPU and tensor parallelism rank. It loads and transforms weights once, keeps them in GPU memory, and serves CUDA IPC handles over Unix sockets. So basically, we're M-mapping this thing here. We're basically M-mapping it. So this like does the work, saves it out into like a very usable format, and then that format can just be M-mapped in. Wait, does it say M-map? No. Oh, interesting. Interesting. So they're actually keeping it in the GPU memory. So that won't solve my problem. This is a big catch. That's a big catch. So that won't, okay, I described my problem at the beginning about how I requisition a server, that server has to like load all those weights, and then it's a big problem because the weight loading takes half the time or more time. What this is saying is that, hey, we just keep those, we do this process once, we keep those weights in memory, and you can restart the server as much as you want, those weights are still in the GPU memory, you just point at them. Well, that's great. If you're that is actually great. If you're restarting your inference server and you're pointing it at a new model each time, or if you're, no, it's like if you're restarting your inference server and not pointing at a new model each time. Yeah, this is a very limited speed up now that I look at it. Because it's like, what is the use case for this? Like, what is the use case? Because the use case is not like, I could understand if you're changing models all the time, because like you've got a process that's doing RL and like saving out new model checkpoints, and you want to restart your server and point at the newer model checkpoint each time. That's not this either. This is like restarting your server because it crashed. Yeah, maybe you're keeping multiple in memory, but at that point, like, you could use that memory for more context parallelism or something. Like you could use it for other stuff. But yeah, I guess, okay, what is this saying? On restart, the engine initializes on the meta device with no CPU or GPU storage allocated. It points each param data directly to an IPC map tensor. No copy, no disk IO, no quant. Fast recovery must preserve correctness. Cache config validates model ID. So I do think they're probably doing something with disk where they're saving out a more optimized, like the quantized version of it, post TP shard, post weight scaling, post workspace buffering, all of that, like saving, I bet they're saving that back out to NVMe disk so that it's faster to load into the GPU memory. 3 modes support practical development. Daemon loads and owns the cache, client connects to it. Daemon loads and owns the cache. I am having a hard time reading this. Daemon loads and owns the cache client, connects to an existing daemon. If a daemon crashes, mapped engines keep running. Yeah, Opus wrote this. It's a load bearing. This is a load bearing. There's a missing load bearing comma in there, or punctuation. Okay, one daemon can also support multiple engines on the same GPU. They map the same physical weight memory, so disk loading. This is what I was saying. So disk loading and quantization happen only once. This does make more sense. Okay, but not so much. Okay, this is solving a problem I don't have. It's cool, but it's not. I thought it was something else going into it. I only saw it today, but I was kind of excited until now I'm reading it. Pi, the question is like, is there any allow list? It by default, it just has access to everything pretty much. I don't think it's locked down at all. You don't have to do a dangerously skip permissions, and you don't have to do YOLO, but it just is YOLO, and it is dangerous permissions. I think that there are ways you can lock it down, but yeah, I don't know. Oh, okay, so this is done. So boot this up on port. What did I do on the other one? Port 1261, I'll say. Prompt to 3D. Timed out. Oh, wait, did I say? Yeah. Okay, here we go. Hey, wow. Okay, Gemini 3.7 is so far, by far, the best. But let's see here. I'm going to take the same... Yeah, like, already, we'll see. But already... Oh, interesting. They gave me a model picker. They gave me detail level. This is a pretty good website. I'm seeing code, 3JS script, that I can close and doesn't open properly. What is that? It's like, did too much, and now I can't even... It's like, this is a lot. I have to reload, though, because once you close, you can't reopen quite. Okay. Why Gemini 2 Flash? I've been using whatever it selects, so I'm going to use Gemini 2.5 Flash. I'm going to have it generate the exact same thing that I had all the others generate. And let's see. Gemini 2.5 Flash is such a handicap for itself, though. But this is cool. Hierarchy, materials. Like, it gave me a little 3D editor. Export. They all have export. That's cool. They all have snapshot. That's cool. Export GLB is kind of neat. It's interesting that it's like working because I don't... Oh, okay. Automatically detected from the environment. Because I'm like, I didn't put anything in here. Yeah. 2.5 Flash, the slop blog post goat. You know what was a randomly good one? Was Gemini 2.0 Flash at tool calling. Like 2.5 Flash was not as good at tool calling as 2.0. I don't know why. It was a randomly oddly good one for tool calling. Still analyzing user description. Hey! It gave like a funky house. Analyzing prompts, synthesizing 3JS procedural geometry and PBR shaders. Running static analysis. Self-healing agent correcting runtime error. Model compiled successfully. Okay. So this is like doing a lot. Like the other ones, much more bare bones. This one was much more ambitious. It set out to do a lot more, but it didn't quite get there. Like, it's buggier. I'm pretty impressed, but also I'd rather it did, like, Qwen knew what its limitations were and stuck to it and kind of nailed its version of it. Whereas this one was a little more ambitious, but it's not nailing it. I want to see what now compare all three with the implementation of Gemini 3.7 Flash. So I will say, like, it was fast, and it did generate a nice, good-looking website. I just think that, like, it needs to be more calibrated to its own capabilities. And also, this self-healing, again, I don't think this did the self-healing loop that both Qwen and Ox Alpha both did. Ox Alpha and Qwen both did a reinforcement loop where they saw their own output, did at least one pass to make it better, and then tried to improve. Whereas Qwen did up to 4 or n, you could do as many as you want, and the Ox Alpha one just did 1. Muse Spark did none, and I'm pretty sure this self-healing was just self-healing a bad tool call. So I don't think this did that at all. I'll be curious what Codex thinks about its implementation. But that's pretty cool. I like that this test ended up being kind of a fun test. This text to 3D model. Yeah, and we'll see what Codex thinks about it. But okay, so I said that this Ant-Ling thing, this new weight cache daemon for SG-Ling, I saw this and I was pretty excited about it. But it's a little bit more like good for production. I was thinking about it more for my production workloads, whereas this, I don't know, I just saw this yesterday and I haven't really tried it yet, but this thing called FreeToken, which looks really cool. Theoretically, it's what it does is it allows better utilization of your existing hardware in your desktop or your laptop or even your workstation. The idea is that you have these CPUs that are actually pretty good at arithmetic. You've got your memory, your system RAM, which can actually do a lot more than what we're doing right now. And if you sequence everything in exactly the right order, you can basically maximize the usage of your entire system. Whereas right now, what happens with a lot of these engines is it kind of like does one big chunk and it's like loads it all into the GPU. The GPU does an entire chunk. The GPU passes it to the next part. And instead of what this is trying to do is like share everything and think about the system holistically, which is pretty cool. I don't know all the details, but what I do kind of want to do is there's this, it says here, okay, so this, let's actually look at it quick. What I think this is doing is it's looking at the entire system from look, we have PCIe, we have this bus, and it is the central bus for everything to go over. And we have all these things that are attached to it. We have the GPU, we have the CPU, and how do we look at the system as the parts of the low level parts that actually exist there, rather than the higher level sort of logical ways that we currently think about it, where it's like a GPU device and there's a CPU device. What if we treat it all as one big shared pool where we can reuse units? Yeah, I don't know what this is saying, honestly. It's a little bit, I would need to spend time with it. But what I did see is that they have this, and the other thing was they're saying you don't have to do conversions from GGUF or source or whatever. And they say that they have a flashml.ai desktop app, which works on Linux, they say. So let's try it. I'll download the app image. Let's see. Let's just see. Releases. So this came out just last week. Oh, but it looks like they've been doing this for a while. July 9th. No, not too long. I do kind of, while it's downloading, I do kind of want to look at the paper. The heck? Okay, FreeToken, an edge-native mixture of experts serving system that treats a personal machine not as a small GPU, but as a unified elastic inference platform. FreeToken co-designs this full serving stack, including model layout and loading, expert residency, CPU, GPU execution, agentic state reuse, and runtime memory management around two realities of local AI. One is that agent workloads continuously change their execution pattern, and two is that edge hardware exposes heterogeneous resources whose balance differs from machine to machine. Rather than committing to a fixed offloading strategy, FreeToken continuously maps computation and model state onto resources actually available. FreeToken supports more than 20 mixture of experts models and real coding and tool using agents across hardware ranging from an 8 GB an 8 GB laptop GPU to a single workstation GPU. More importantly, it changes what these machines can practically serve, from a 35B model on your laptop to a 284B model on a gaming desktop. And the 753 gigabyte GLM 5.2. I'm curious about this. Like, could I get this to run GLM 5.2 on my machine here? That would be cool. Wonder what performance it has. Okay, this is saying FreeToken on 4060 with a laptop gets 40 tokens a second compared to Ollama and Llama CPP. Double. Okay, so what I'm getting from this, basically real quick, is that I'm not seeing any dense models being compared on here. These all seem to be mixtures of experts models that are, so okay, so it must be a lot of the optimization must be about what experts get put where. Okay, let's see where we are here on the download. Wait, I have this like, let's see if this works today. Oops. This is version. Okay, let's see. Does this work? It's not looking good so far. I'll quit it. Classic Linux. Not good. Wait, let's see here. I'll download the Arch Linux version. And then I'll just say, actually, I'm going to uninstall this last one. Oops. Oops. Uninstall. And then actually what I'm going to do, I don't know what to do with the CST file. Crap. Let's see what it says. Okay. I didn't know I could just Pac-Man U it. Love how I'm installing some random software from some random place. It's always good. I don't want to remove it. Hey! Okay, let's just start with .FreeToken models. Okay, for now, that's fine. Hugging Face official, sure. Mainland China mirror, maybe not. Install the FreeToken engine. Download 7 GB of PyTorch. Okay. It's actually kind of a nice little UI so far. But this is pretty bad. It's like doing NVIDIA stuff. Does it require NVIDIA? Oh. Doesn't support AMD. I guess. Let's see. It's not looking good. Okay, let's see what the 3D modeler thing had said. It finished investigating. It read all the stuff. Gemini's feature breadth is exceptional. Gemini's feature breadth is exceptional, but its observed generation failure and server-side execution model materially changed the overall ranking. Oh my gosh! My local Qwen! My local Qwen still won! The Qwen that's running on my desktop over in the other room won over Gemini 3.7 Flash, over the new hyped Ox Alpha, over Muse Spark 1.2. Like, that is so freaking impressive. And it's not that it like made the most amazing product ever created, but it followed my instructions. It didn't try and get to, it was well calibrated to know what it was capable of and not go past that, and gave me basically a sketch of what I wanted and not more. And it didn't take on more than it could do. But what it did take on, it kind of nailed. Okay, let's see what this is actually. Okay. Qwen remains the best implementation overall. Gemini has the largest feature set and richest interface, true. But it ranks 4th because its core generation failed in the match test and its execution architecture has serious robustness and security problems. Scores are goal-weighted. Producing a correct model and handling failures safely matter more than the number of advertised features. I like that. That's a good calibration and good scoring rubric. Okay, Qwen, overall 8. Muse Spark, overall 7.2. Ox Alpha, overall 6.8. Gemini 3.7 Flash, get a 5.4. It's the worst of all of these. I can't say that I completely disagree either, because I didn't ask for all of this and it didn't nail it. Like this, I don't know. Let's see what this said. We can skip past some of this. Okay, Gemini 3.7 Flash. Gemini is the widest implementation by a substantial margin. Multi-state generation, refinement history. Oh yeah, refinement history if you direct it. Animation controls, material inspection, multiple lighting modes, extensive export options, and a polished interface. Its build succeeded and all 12 supplied tests passed. However, the central workflow was the least successful. The identical house request took 76.4 seconds. That's a little bit down to the model, but why did it choose that model? The first generated program had unexpected token if. Weird. Its one self-healing attempt produced another syntax error. Unexpected token. Yeah, it's bad. No house was created. The old hand-authored hover speeder preset remained visible. The two-stage generation and one-shot repair logic are in. Okay, so it did do one repair. One-shot repair. But that's not what I asked for. I wanted a refinement loop. More seriously, Gemini's advertised static analysis / runtime sandbox directly executes generated code using new function. Oh, bad. A targeted probe confirmed that server executed model code C process environment variables. So that's like none of the others had like as much security concerns. This literally generated like remote code execution. Other correctness gaps includes an empty scene is accepted as successful. Another poor one. The only one that didn't do that was the Qwen one. Provider callback can forward a user's Gemini override key as a bearer token to unrelated providers. Ooh, that's bad. Animation controls capture initial state, so pause, speed, and auto rotation changes did not reliably affect the running loop. Animation was just really half-baked. It added animation, but it messed it up. Still on HTML, still loads 3JS from CDN. That's okay. That's okay. Its advertised 4K capture is actually 1080p. It's like it wanted all these features, but it didn't know how to follow through on them. The production bundle is roughly 1.17 megabytes, significantly larger than the others. Not great. This is interesting. So the takeaway is, if I were selecting one to use today, I would choose Qwen. If I were selecting a code base to harden and extend to a production system, I would seriously consider Ox Alpha's declarative architecture, augmented with Qwen's rendered image evaluation loop. I agree with that. I agree with all of that. Like Ox Alpha, the declarative architecture where it created the scene graph rather than the whole 3JS thing, I like that. But I like that Qwen actually included a vision model. Big difference. Big deal. Okay, we're done installing FreeToken. I don't think this is going to work anymore. I was excited about it, but I think this might be NVIDIA only. Let's see. Cost saved. Recommended for your hardware. Okay. It's suggesting NBFP4 stuff. Cache config. Chat. API endpoints. Launch an agent. Oh, okay. Cloud code that launches pointed locally. And logs. That's nice. I can always rerun the onboarding. Okay. Confirm. Let's just do GPT-OSS 20B because it's small. I guess that's relatively small. Okay, we'll do this. It's a good settings while that happens. Oh, they don't have Pi. I don't know why a lot of these companies, they all seem to include open code, but I like Pi. It's strange to me that open code gets included like everywhere and Pi never anywhere. I guess OpenClaw includes Pi, so that's fine, I guess. Okay, well, this is downloading. I want to switch gears a little bit. We can just let this go in the background. I don't think it's going to work anyway, so we'll let it download. We'll see if it works. If it works, I'll be amazed. I'll be happy. We'll try more stuff, and we'll see how fast it is and all that. But I think it's built all expecting an NVIDIA chip. And if it expects an NVIDIA chip, we just won't be able to run it. It's nothing we can do. But I did kind of like, there's other stuff that we can talk about here. Let's close all these things that we have open. So I want to talk about, oh, interesting. Whoops. I think I messed up my, I want to talk a little bit, okay, you've been seeing me use like you've been seeing me use voice to text, I think, in the course of this stream today. Like I've done, this is a test. This is only a test. Tell me what you think about everything. I don't know. Let's see what happens here. Scratch that. Period. What I think should happen is that it should just transcribe everything that I say, and if I ever mess up and want to go back, I can just say scratch that. Period. Comma. Period. Space. Okay, space doesn't work. So scratch that, 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 scratch that. So, okay, what is this? Here, let me stop this. I'm going to open a new thing because I just want to like start a new one. I don't know why. So, what is this that I'm using right now? What is this that I'm transcribing and is doing all of this for me? This is an open source software called Purr. P-U-R-R. Scratch that. P-U-R-R. Period. It is actually a Mac app. So the first time that I saw this, it was because I was looking for a piece of software that would be something kind of like a whisper flow, but I didn't want to pay for it because I know that there are these great models that are out there that like do this great, and they don't even necessarily need a whole lot of GPU. But if you have a GPU, they can even run on that. Period. And I know that there are whisper models which actually kind of like in one chunk transcribe everything. But I also know that there are these like live transcription models like Parakeet and some of the newer ones from NVIDIA, which transcribe live as you're typing. And that's pretty cool. I think that's like a pretty useful thing. You can see I've used it in this stream already to do things like typing to the agent and to make it like keep the flow going in the stream as I want to just say something instead of having to type it. Also, like if I'm typing in the stream, sometimes you hear that in your audio. It's like not great, right? So it's nice to be able to just say things out loud and have it transcribed and sent into the whatever window I'm looking at. So that's what this is. And it's this piece of software called Purr. And like I said, okay, let me stop this. I actually found, like I say, here we go. So at first I was looking for just different options for something that's a little bit like whisper flow, but that I don't have to pay for. I also don't want it to go through a cloud of any type. Like for a lot of these things, like, I don't know, I don't want anybody listening in on it. It's just like, maybe it's coding work that I'm doing. Maybe I'm working on a project I don't want to share yet. Whatever, it's just like makes me uncomfortable for that to always be going through somebody's server and listening to my voice. The other thing is that like the more recordings you have of my voice, Like, there's more voice recordings out there to clone my voice, and I don't want that out there in any like scams or phishing attempts or database hacks. I just don't want that. So like, I was looking for an on-device solution, and I was on my Mac, and I found this. I tried a couple of different options, and eventually I landed on this Purr, which it does the basics. It doesn't do a lot. It doesn't have like a whole ton of configurability, but it does the basics, and it all does it on device. The problem with it, so there's two problems. The first one is that if you just install the Purr DMG file from the GitHub, it has a pretty big bug with live transcriptions where it will, like, after the first chunk gets sent into the input window, whatever else you say after that just gets deleted. It doesn't, it's like a bug in the software. But I found that, like, if you go to the commits, there's this commit on June 16th, which says enhance audio streaming and text insertion logic. And it fixes that. So I found that, like, okay, the first time I installed it, I'm like, this works great. And then I hit that bug, and I'm like, this sucks. Like, anything that ever loses your speech data, that sucks. Like, it feels really bad. You don't trust that software anymore. That was really a bad situation. So I almost switched off and found something else. But I came down here and I saw, oh, there's this quick start where you can just compile. It looked pretty easy, and it was pretty easy. And I was able to just get it running on my Mac. And I've been using it, and it's been great. Like, it's been a great little Mac app, and I'm able to use it for the little, like, transcriptions and dictation that I want. That's a little bit better than the built-in Mac one. It's actually a lot better than the built-in Mac one. And it's cool. It's like a nice, good UI, and it's pretty neat, right? But I was on Linux, and I realized that I wanted something similar on Linux. And I was kind of looking around, and there wasn't a bunch of great options. So what did I do? I cloned this repo, and I gave it to Codex, and I said, make this work in Linux. Like, port this to Linux, basically. And it freaking one-shotted. It one-shotted the port. And so that is what I have been using. Oh, wait. What's all this? Like, my dictation is still, it's still like, oh, here, let me just close and reopen. See, this is what the problem you get sometimes. Stop dictation, quit. Oh. Anyway, with all that being said, so I basically just had it port, and I ported it over to Linux, and it was a one-shot thing. I literally just said, and at the time I said, I don't care about making this public. This is a fork just for me, for my own reasons. So don't worry about maintenance. Don't worry about anything. Just, like, make it work. And then it worked, and I was using it reasonably well. I will say it wasn't 100% one shot. Now that I remembered something. It one-shotted a good port that made it work and chunked everything properly. I had to guide it once more in, like, one more loop or something to make it live transcribe into the text box. So what it was doing was what was like, I would transcribe, I would type, I would transcribe, I would hit the hotkey, it would start transcribing, and then I would stop it, and it would put that in my copy buffer, and I could paste that anywhere I wanted. But what I wanted was that, like, sort of live streaming that you've seen transcription, so that as I'm talking, it's typing into whatever text box. And it took one more push for that to happen. But once I was able to do that, it was pretty cool, and it's been working. It was working great. And then later that night, I was like, oh, wait, there are other models out there. I could try other models. So I just prompted Codex. I said, add support for more different models that are out there. And so now I have support for, like, all these different models. It downloaded them, and it made it possible for me to switch between them. So, like, here's an example. So this was the one that we were using. Now I'll switch over to this. I'm using the Parakeet Real. Actually, before I do that, I'm going to switch over to the Whisper Large Turbo V3. This is kind of like the standard one. So let me create a new doc, and I'm going to start transcribing. This is what it works like when you just use the standard Whisper library, where Whisper kind of wants to take the entire chunk of text at the very end and transcribe it. And that's great. It does a great job at that. But it's kind of like it's not as great as if you can see it all happening live. So I'm going to stop the transcription now, and we can kind of see it go. Yeah, wait. Oh. Yeah, so it did a transcription all at once at the very end, and it's a good one. Like, this is what it works like when you just use the standard Whisper library. This is a good transcription. In fact, it might be better than the streaming transcription that we saw earlier. But it isn't a good user experience. So it's kind of nice to just have both. If I wanted a really, really precise transcription, I might use this large V3 Turbo. But if I want to like kind of have a better user experience, this is definitely a much better user experience because you can see as it's typing and you basically get instant feedback on what you're doing. And also this is something that allows you to do something like the scratch of that. So I can say scratch that, and then it deletes it. And that's just not something that even really makes sense in the kind of model where it only transcribes at the end of your utterance, like at the end of what you said. If you've been saying scratch that, it's just weird. It's a little bit weird, but it works better if you do have like this sort of live transcription thing, right? If I stop it. But here's the thing. There's other live transcription models. So this is like a reasonably recent Nemotron model, but there's also new ones. Like there's this smaller 120 million parameter. This is a very small model now that I can switch over to. So let's test this smaller model and see if it's better or worse, or if it's faster. It seems to me like it has a different style of transcription, and it doesn't like do as many capitalizations, and it's a little bit faster. So I'm seeing my speech faster, but maybe the accuracy is a little bit lower. So it's kind of a trade-off that you can try, and you can pull in different models. So this was just like literally a one-shot where I did the one shot that brought it over, and then I did the one other steer that said like make it live transcribe and paste into the text box. And then I did one more thing where I said bring in all these different models and allow me to switch between them. And that was it. That was it. So I just wanted to this is the reason I'm bringing this project up is because I have all these little, I don't talk about all my little projects, but I have all these little projects that I have where you don't have to start from scratch on stuff. You can, with an agent, you can actually just start from a pretty good Mac app or a pretty good open source Windows app and just say this is my starting point. Let's port this over and let's use this. And you can expand upon it, and now it's your Linux app that does exactly what you want. And then it's yours. You can contort it to whatever form you want it to be in. It's pretty cool. I think it's a pretty cool thing to just have this. This is one of those mind-opening things for me where I was thinking about starting a new project from scratch, right? That was my initial instinct was let's just make a new project that does audio transcription. But then I realized that I already had an open source app I kind of like on Mac, and I can make it my own. It's open source, and it's MIT. It was a really open license of open source. So in the end, after I was, like I say, my original instructions were that I did not plan on open sourcing this. I didn't plan on releasing it to anybody. But then I'm kind of why not, right? It's MIT. If I make it really clear that it's not my project, I go to the original project if you want that. But then I gave one command and I said, actually, is it still open? No, it's not. But I basically just said, get this ready for public release, swap out the screenshots for Linux screenshots, and swap out the README for stuff. And now it's on my GitHub. So I have a GitHub version of Purr that links out to the real original Purr right away at the top, so you know about that. But then the screenshots are not of the Mac stuff. The screenshots are of my Linux copy, and it shows examples of how to get it running on Linux. It shows all the hotkeys and stuff. So this is now my Purr app, and I could throw it away tomorrow and find a different thing and start a new one, but I don't know. I'm not trying to promote this or push it or anything. I just kind of had a cool mind-opening moment where I wish that I had something similar to what I had on Mac, and I just made it happen in like 2 or 3 prompts. And yes, I used Codex. I didn't use an open source model for this one. I used Codex. But I could, I'm sure, now that I've seen some of the things that Qwen 3.8 27B can do, I'm sure it could have done this. I'm sure it could have done this. It didn't take all that much work. So let's see. Let's see. The big commit that did it all was this. Add local Linux Wayland dictation support. And then, yeah, fix GNOME live dictation shortcut delivery. This is where I was saying it wasn't transcribing into the text box. And then this was maybe a bug fix? Or maybe it did all these 3 commits after I said that one thing. Maybe that's what it was. And then, yeah, prepare for Linux release today. Because I was like, I'm going to talk about it. Might as well just release it. If you're running on my exact version of Linux, it might work for you. But if not, guess what? This is the formula. Like, just fork mine, give it to your agent, and say, make it work on my system. I don't know. I'm just like, it was kind of a cool, mind-opening moment. And I just think like there's so much unlocked potential here. There's so many great open source projects that run on Windows, run on Mac. And if we're trying, and like, I'm not like trying to be this big Linux enthusiast, but like a lot of my dev stuff runs great on Linux. And I just want some of these nicer consumer application type things on there too. So I don't know. This was just like a fun, cool moment. Okay, let's check in. Okay, convert failed. Qwen 3.6, 35B, A3B could not be converted to FTW. The source weights are kept so you can, I guess I can retry. I think the problem it can't be converted is because it's probably trying to use an NVIDIA tool and NVIDIA can't be installed. Okay, this project needs to do some work to like stop you from getting this far. I shouldn't have been able to get all the way here. I shouldn't have been able to download the model. I shouldn't have been, when I even booted it up and it was asking me to install that stuff, it shouldn't have allowed me to just get this far. So I am going to delete the model. I want to try and clean up after this. I'm going to uninstall this. I'm going to delete the model. I'm going to, what is this saying? Auto pick hardware. Okay, I'm going to get rid of this. Okay, first of all, I'll close FreeToken. Oops, I didn't mean to force quit, but why not? What was that? Like I had asked it before. Okay. To remove it later. It knew. It knew. Ah, what's going on here? Oh no. Okay, so that's gone. I'm just gonna easier. What if I had just like deleted my entire repository or my entire hard drive right there? Like I accidentally put a space. Well, that would have been bad. What's my laptop's temp at? Oh man, it is still hot. It's overheating. It's overheating. Okay. You know what? I'm going to save. So yeah, this Purr thing, the reason why I'm talking about it is because like I kind of want to do, like I do so many projects in a week. Like I do so much random stuff, and I kind of want to start just talking about each week. I kind of want to talk about what I did in the last week. But there's so much. Like I don't even know if there's time to go through it all, and there's so much that like requires a lot of explanation. So like the Purr one was a quick little one that I could share easily. But like this week, I did these 3 projects. I started these 3 projects. Although Super Storygraph is a project. Okay, let's talk about Super Storygraph first. Super Storygraph is not a project that I started last week. It's something that like I, on a whim, kind of like started experimenting with maybe March or April of this year. And the idea was, at the time, at the time I was thinking about like how bad LLMs are at story generation, like how bad they are at narrative, and how everything is so collapsed, where it seems to always pick the same names of people. It always seems to pick the same stuff. So here, wait, let me just go. Let me kind of like clear out some space. Oh my gosh, I got a lot of tabs open after all this. Okay, so let's start something new. Okay, CD development. Okay. So first of all, I will use Pi. Why not? And I will use, let's just use my desktop one again. And this time, you know what I'm going to do? I'm going to do low. I've been hearing about how low, Qwen3.8 27B at low can be almost as good as the X high. But I haven't tried that much yet. So let's actually try that for this purposes. We'll see if it's good enough. If it's not, we'll change things. We'll figure it out. But what I wanted to do is, hey, so I'm in Super Storygraph right now. And please boot up, start running. Oh, I'll use my dictation. The Super Storygraph prototype website, so that I can explore it and share it for people who are watching my stream right now, and share with me the URL, the local URL that it's running on. So when I said that I was thinking about just like, okay, let's just think about stories. Actually, I will just say that I was a game developer for like 10 years ago. I was a game developer. I built this VR game called Soundboxing. But and I wasn't actually super into games before that. Like I had a period of a lot of my life where I was really into games. Growing up, I loved games. But then there was like a 10-year period where I was like right after college, where I was in industry. I was like more focused on coding and software projects and all that other stuff than games. And that's how I got into, and when I went into VR, I got into like the VR space. I initially got into VR with the idea of not making games. I wanted to make like a Reddit browsing app, or I wanted to make like software for VR. But I ended up having to pivot because software was just not ready, and VR was super oriented towards games. And so at the same time that I started building my own games and building VR games, so like I was thinking I'll build games until the application space gets more mature and it gets ready to go. And we'll transition into more talk about VR later. But because I started getting into that again, I thought to myself, I need to start playing games so that I know what the current zeitgeist is around games and what is expectations and what are like the standards and the tropes. And I just needed to get back into games and learn them more. And in that process, I got really into open world games. So I loved the like Assassin's Creed Origins, and how like you could become this character, and then there were all these stories littered throughout the world. And The Witcher 3, there were great stories littered throughout that world. And then like the Horizon Zero Dawn was an incredible game around this time when I was getting into it, where it's like all of these, like the Assassin's Creed Origins, Witcher 3, and Horizon Zero Dawn kind of were this trifecta of incredible open world games to me at the time, where like, yes, you've got the graphics, yes, you've got the world building, but really it was like the ability for there to be narrative moments within that world that were self-contained and made sense within the story of the world, but like you could explore them on your own terms and get to there on your own terms and have like a really like emotional experience while you consume these stories in the world. And especially like The Witcher and Horizon Zero Dawn. Like Horizon Zero Dawn has some of the most incredible storytelling that you learn through like even through like reading notes and leftover messages from people, and you start to piece together the world and the story about things. And then there are some reveals that happen, and it's like I was thinking that is so cool, but like it's so hard and so expensive to build an open world game. You only get one of them every few years. Like, and even then, they're coming fewer and further between. And it seems like the thing that they're most willing to give up on with these open world games is the story. They're not willing to give up on the graphics. They're not willing to give up on the world building. They're not willing to give up on the gameplay, although all of those are debatable, depending on what sort of like your take is on some of the latest things. But the first thing to go when they're starting to like cut back on these open world things seems to be stories and narratives. And so I was just thinking to myself, like, in the new agentic world, we've got this ability to generate infinite worlds, right? The world building is kind of free. And the graphical abilities of these models are getting better and better and better. And like they're even like what we saw earlier today, where we were doing 3D models, using agents to run 3D models and create new 3D models from scratch using primitives. Like that's already getting a lot better. But the thing that seems to be getting worse is like the narrative story build and trying to build an emotional core and memorable characters. And so that was what led me into thinking about all of this. Was like, okay, let's just like start tackling this. Let's just think about how this would work. And so my first attempt was just literally just prompting Claude to say this, to not just try and one-shot a story, but to first of all draft a graph of a story in a structured format, so that there's like edges and nodes, and there's characters, and there's places, and there's connections between them, and there's little story chunks, and that like, and generating that like a sketch of that first, and then refining it and saying, okay, let's find parts of this to flesh out. Let's make sure that this all agrees with each other. Let's make sure these stories are self-consistent and the plot lines make sense and line up with each other, and that the characters are unique each one another, and that they're acting according to what their character should do, and all of that. And so I just kept on saying, and this was just an open-ended vibe coding prompt where I'm literally just like refining it, and saying, check for any disagreements, check for any mismatches, check for like tropish type things. And I got to the point where like then I had a pretty decent, it was like a YAML file. And I had a pretty decent sized YAML file that like I could, then I was like, okay, now generate something for me to take this YAML file and generate a website from it. And then I said, okay, now take that website and generate, and I used GPT image something at the time. And I had Claude prompting GPT to generate the images. And I said, like, generate character profiles for each one of these people and generate environment profiles. And then like use that all in the website. And I ended up with something like this, which is what I'm going to show now. And this is the prototype from like March or April or whatever. And it created this story called Threshold. And I lost the original website generator. So this is a recreation of the website generator, but I found the old YAML file. So it's like it's all the images and stuff. So that, again, like this is March, April, and I kind of like lost track of it, but it's stuck in the back of my head because like it turned out really cool. Like it didn't turn out perfect. We're not there, but it's definitely like to the point where, well, you'll just see. Like first of all, like that, like there's really cool character it like has a decent amount of structure and complexity and formats and all that other stuff. But if you get into the story, like the story is kind of a little bit whatever. But if you go through it, like the way that the images all line up, and then I forgot, I generated audio. Where is it? Where can we?
I've seen 6 children with severe dehydration today. 6. The youngest is 14 months old. 1 liter per person per day is not enough. It was never enough. And while the factions argue about politics, there is a baby in my clinic who does not care about sovereignty. She just needs water.
So like I created these little.
I've seen
Like,
6
it's
children
not a
with
whole
severe
story,
dehydration
but it's
today.
like snippets of it that you can kind of get a
Youngest
sense
is
for. It's like a
14 months
previs
old.
of a story.
1 liter per person per day is not
And
enough. It was never enough. And while the factions argue about politics,
characters.
there is a baby in my clinic who does not care about sovereignty. She
These
just
aren't
needs
great
water.
audio.
Every single one was denied with her. He told me the pressure gauges were reading wrong. He told me the seals were degrading.
Okay.
My
So,
brother filed
but if
17
you look, but if you go
maintenance
from the top
requests
to the
for grid
bottom,
7 in the
it
last
does
year.
kind of create this
17.
compelling something. There's something
Every
here.
single one was
It felt
denied
like there's
or
something
deferred.
here where it's like,
He told me the
okay, and I
pressure
can
gauges
click
were
on like
reading
a
wrong.
character
He told me
and
the seals
see
were degrading.
all the different stories that he, like all the different stories he's in, who's he's allied with. I can click on that person and see like character images of them. Look at this, like this is a cool character that it created. And then like if I want to go to look at the entire cast, this is the cast that it created for this thing. And you can click in and see like, okay, the antagonist is Hans Richter, who is the, Pelagic Industries board member based in Hamburg, never lived in Threshold, represents the shareholders' perspective. The platform is an asset, not a homeland. Blah, 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 blah.
You may call me a vulture. That is your right. But while you were negotiating in this charming underground bar, I was ensuring that threshold supply lines remain open and its debts remain serviceable. Sovereignty is a beautiful word, but it does not desalinate water. It does not.
You may call me a vulture. That is your right.
It does not.
But while you were negotiating in this charming
Okay.
underground bar,
So you can
I
kinda
was
see-
ensuring
oh,
that
and then there's
threshold
this
supply
ghost,
lines
the
remain
ghost.
open and its debts remain serviceable. Sovereignty is a beautiful word.
Cool, like I love
But
the
it does
imagery
not
that it came up
desalinate
with.
water.
And the imagery is
It does
all
not pay for
reasonably
food
consistent
shipments.
because it was all
And it does
given
not
the
keep
context
the lights
of
on.
everything. It all had like piecemeal placed context from the rest of the Storygraph. And this is all that was this is all just that like prototype that I built last in March, April, or whatever that time. And you can go to the world. These are all the different. These are some of the different areas in the world. The Pelagic Tower, the Diplomatic Quarter, Desalination Grid 7. But then you can also like you can do all these. It's a graph. It's like an actual structure. So you can do things like this, where you can click in on like the main character and see all the like the story beats, the confrontation event, the 22 years event. I don't know. So the story is a little bit meh, and that was the whole point. But but this led me to the idea that instead of trying to one-shot the story, to try and create a structured graph of the story, and that like there might be something here. So this is a project that I think last week or something I sort of just started picking back up again, and this is what I was testing Muse Spark 1.2 on. Is that like, okay, let's take this and start to turn it into like something more repeatable. Like I was just prompting Claude, so this wasn't a project or anything repeatable. It was just like a one-shot task that I was continuing to just iterate on. But recently I started thinking like there was there was this whole blow up recently about the Assassin's Creed narrative storyline stuff and the writing on the Assassin's Creed games. And they were talking about how there were people who were like talking about how it's gotten so much worse over the years, and how that's like really declined and gotten a lot worse. And so that's what kind of re-kicked me into thinking about this project again, thinking like, okay. And I've been seeing so many one-shotted games recently, especially with like Opus 5. When Opus 5 came out, people were putting these things together called gauntlet loops, which created like really high quality assets, really high quality worlds, but like populated by kind of nothing, populated with these bare, like either it was just gameplay or whatever. So I started this. I revived this project. It's a vibe coded project. I haven't really read the code very much, but this is much more of a structured attempt at it now, where like I'm generating the graph and then doing evaluation and refinement loops as part of like the graph generation process. And like trying to, and the other thing is I'm having it so that like it starts with a kernel of an idea and then it creates a graph, it builds up a graph around that idea. And then I have this concept of like having it, like it projects the graph into a book, a movie series, or sorry, a TV series and a video game. And like you can have the same the concept of like the graph is what happened in the world, and then you can project it down and convert it into these different sort of like formats for like a season of a TV show versus a movie versus a book or something like that. And so let's see if there's anything more to talk about. I'm not like, I don't have much to share, but it's like I've been working on it. It's just something I push forward periodically a little bit here and there. At one point I did like intro. Yeah, okay. I put together like, because I had like submitted a bunch of work in a goal mode to this, and I had it using Muse Spark, and I was having a hard time following its actual progress. Like it seemed to be making forward progress. It was on like iteration 72 or something, but like I actually didn't really understand what it was doing in the end, because like I felt like it started getting away from me a little bit. So this is kind of like a little trick that I haven't even gone in and looked at it, but I gave it a goal and said, imagine you're like new to this repository. Give me an introductory directory to this repository that sort of slowly guides me through things and doesn't fake things. It doesn't create like it doesn't like stub out or create fake versions of things or do like less than the real project does. It should do everything that the real project does, but cut down. So if there's going to be like a gauntlet loop with like 5 different iterations and like 3 different subagents or whatever, just do one, or like show me one version of it and show me a minimal. And instead of generating the entire story, generate a chapter. Or instead of like generating the full graph, generate like a densely connected subgraph node. And then create a step-by-step introduction directory where I can go through and teach me each one of these concepts and reveal a little bit more at a time. So I had it do that, and now I'm like here on stream. I'm going to kind of go through it a little bit and see what it ended up creating, so we can learn about it together. So I've given you the like the prototype and showed you the prototype. But now let's go through and walk through this introduction so I can show you like what the real project is doing right now. And like it's gotten a lot further along. The definition of the graph has gotten a lot more. But also, wait, before I even do that, that web project is like specific for the prototype. But once I got that working, I said, okay, now create a web project, a web viewer for my real generated assets. And now I will say that I am doing everything in story and graph mode first. I have not done the generation of the like the images and the audio and all of that, because I feel like I need to get the basics right before I do any of the media generation. But even then, I was looking at, so this is these are all the different stories that I've created in the process of developing this software. And a lot of it was using Muse Spark 1.1. But for example, like you can see, let's see. I don't know why there's so many. I don't know what these groupings are. But let's look at one that completed and didn't fail. So this was generated 8:10. So I guess it's like I said in the last week. I guess I've been working on this for maybe 2 or 3 weeks since then. But like on and off, not too much, just a lot of like proceed, setting goals, pushing forward. So what happens? You've got this like viewer where you can see the entire story as it, and like before when I was showing the story graph of the existing one, you get something very similar for this. Only as you can start to see, this is a more complete story. Like there's a lot more nodes and densely connected events and things that are happening because I've gotten it to a lot better place than the original one was, and it's more of a story factory than it is like a one shot that I've been guiding it. This is much more of like, as you can see from this, it can generate more and more and more and more, and I'm trying to like hill climb and make it better and better each time. But anyway, you can start to see that like, who's the main character? In this case, it's Mara Vale. And I do need to make the name selection better. It constantly chooses these similar names. But that's part of what I'm doing. Okay, that's another thing, is that, okay, when you start to generate these story graphs, you start to see all of this like entropy collapse that starts to happen, where like it picks the same names for every story, picks the same locations, picks the same whatever. So now what I've got is like, because I've done a bunch of these generations now, I have judges that are looking at not just like the quality of the generation, but the creativity compared to past generations. So as it's generating slop names and it's matching to old slop names, those are getting bad scores, and it's feeding that back into my system that's trying to improve that process. So I mean, like there's a quality in quantity all of itself, because as you start to increase your quantity, you start to see where the entropy collapse happens, and you start to see where, you know, so especially in some of these like smaller models where they start to like fall apart a little bit. The bigger the model, they kind of seem to keep more of their entropy, I've noticed. But let's see. But yeah, it generates like an entire, this is an 83 chapter book. So that's another part about it, is like creating prose that is good, and creating loops that make sure that the prose is always being improved upon until it's good. One sec. Okay, I had to turn on some lights. Yeah, so I have done a lot of iterations to try and make, oh, here we go, generated by GPT-5.6, Luna. Oh, yeah. So I said I was using a lot of Muse Spark, but I was also using a lot of GPT-5.6 Luna, because it's just so cheap. It's just cheap, and it's good. But I don't know. Okay, so that's that. Let's go through this little intro. I wish I had like read this a little first. Okay, I'm gonna shrink some of these down. Oh crap, I actually don't want that. Okay. But let's walk through this intro, because I asked it to create an intro to help me learn more about like the latest of this project. And as I go through it, hopefully you all will learn a little bit about it too. But yeah, okay. Live introduction. This directory is a presenter-controlled tour of the real Storygraph, Super Storygraph codebase. It does not contain a miniature pipeline. It loads the production Storygraph, runs the production validators, form, mass, projection checks. So it checks for form, for story mass is what it calls, like I guess the density of like where the parts of the story are going. So like if you look at that graph, there's nothing super uneven about it. And projection means like creating a book out of it, creating a series out of it, creating a movie out of it. Renderer, screenplay parser, diff, eval registry, prompt builder, and run manifest reader. Treat it as a curated distribution of the project, not a reimplementation. It uses smaller, versioned inputs and stops between lessons, but it does not relax a validator, lower a form target, replace a production algorithm, or hide a failed gate. Keep two connected loops in mind throughout the tour. A run is canon, creating canon first, with deterministic gates, and then judgment of it, then revision, and then forms. I guess that's like the projected forms, and then archived evidence, which is like, I guess, the stuff that this is loading. This is loading all these archives. To learn, the learn loop is human correction, gets turned into an eval case, gets turned into a judge that must re-earn trust. Okay. The second loop is deliberate, not automatic. Merely archiving a run does not improve a judge. So yeah, it's all about like, this is what I realized, is it's these loops of judgment and improvement, and judgment and of improvement. And I realized that my own human input is most valuable not at looking at the exact, like at looking at a story and judging a story, but it's like looking at the judgments and improving the judges so that the judges can scale. And that like, as long as the judges agree with what I agree with, that they can like continue to make judgments that are closer and closer to what I would like. The second loop is deliberate. Okay. The default path is deliberately offline and normally finishes in well under a second of compute. In an interactive terminal, it pauses between sections so the presenter controls the room. Okay, let's try this. Make intro. Oh, okay. Super Storygraph, guided tour. Oh, it made a whole like interactive guided tour. That's cool. Curated inputs, production algorithms, unchanged gates, inference opt-in. Okay, 2 loops, not 1 prompt. Story production is repeatable, improvement is separate, measured, human feedback loop. Production stage boundaries. A is ideation. Generate, adversarial review, and select concepts. Then it turns into graph generation. This is, ideation, it's like creating, And then the graph generation says, turn the selected concept into the typed canonical graph. And this is where I was talking, this is like what I was talking about earlier. Then you take that graph and you validate it. So what I was doing manually, where I was telling Claude to just look for things and fix it, now we have these judges where we can create judges that like more and more align with what we want. Media, I am skipping for now because I just want to get everything else right, perfect first. But then rendering is this concept of like projecting that graph into different form factors, like I said, like a book, like a TV series, or like a movie or something like that. You could have the same set of events. Like imagine like there's a real world event and you want a historical, like you want a book out of it, a movie out of it, or a TV series. Like, but it's all based on like some graph of real events that really happened in life. Discovered from pipeline stage subclasses. A, B, C, and E have code. D remains an honest gap. Yes, because I'm waiting to get all the other stuff right before I spend a lot of money on image generation and audio generation. Production exposes 4 typed stage boundaries and an explicit media gap. Archiving evidence enables learning. It does not make learning automatic. Yeah, so the fact that all of these exist doesn't mean you're getting better. But because these exist, I can comment on them, I can feed that back, and that can then make them better. Okay, what does this want me to do? Enter. The canon, the single source of story truth, is a typed story graph, not a model's fading conversation. So this is what I was talking about like, it's all about refining that graph first. Threshold, 92 nodes, 392 type edges, near future political thriller. This was the one I showed, Threshold. And this is like just an example of all the different nodes. There's 5 artifacts, there's 15 characters. You saw some of that. The canonical event order. We have the status quo, we have a failure, we have this big event, the cascade failure, and then we have like a 3 weeks later. Okay. Now we're going to check the story structure like software. Deterministic defects should be found in milliseconds without spending inference. So we have we can look at the graph and say, hey, there's not enough depth in this graph. So there's like ways that you can mechanically look at the graph without necessarily using an LLM judge. So you can say like, this particular portion of the graph doesn't have enough nodes. It doesn't have enough. It doesn't have enough connected nodes that are deep enough, basically. Or like this edge doesn't connect to that. Like there's no connection between this character and that character. There's a logical problem because they're supposed to be interacting. They have this thing. We have a scene with them interacting, but we don't have any event where they've ever met before or something like that. Like you can find broken parts of that graph that don't make sense, basically. So those cheap ones are easy to run quickly. This is cool. This made this like whole explainer. Claim, passing syntax is not enough. Canon must carry enough observed narrative mass for its form. So that's like basically you can do these analyses and figure out which parts of the graph need more work, or whether the graph is big enough and full enough to do what we want. So this is an example of like, wait a minute, if we want a novel, we're gonna need more than 50 scenes. So there are these like hard-coded, like you can put limits in for like the type of projection you're trying to create. And this is where I started to see, I've seen, this isn't a finished project yet, and I've seen this is where things go wrong, because it starts to make things be a little bit more too formulaic, where it invents scenes just to invent scenes. And like, I started out with a lot more of these checks, and then over time I have relaxed them and created more LLM-based checks, where it can take into account all the context of everything surrounding it. And it's not as much hard-coded stuff, or not hard limits and things like that. But it is good to have like a baseline set of these things to just do graph health type stuff. So this takeaway would be like, threshold is valid canon, but it's like valid. It's connected. There's a few errors, but for the most part, it's a valid graph. But like, if we wanted it to make a novel, if we want to make a novel out of it, there's not enough stuff. We don't have enough stuff. So, claim, deterministic checks run every time. Expensive readers are version evaluated and invoked only when useful. So this expensive readers is when it's meaning like an LLM judge, I think. So version judgment assets, no, oh wait. Yes, Graph Judge v3. Yes, and there's a prompt that we built for it. So this is like, I've been iterating on these prompts and these judges that are being created, and this is an example of one. It can evaluate artifact quality. I can evaluate the alignment of the judge, and I can evaluate whether it's improving with improved revisions. Recorded corrections, which are from me, which this is what it means when it says recorded correction, and prior review decisions are durable memory. So every time I'm correcting the model or I'm feeding back to the model, that becomes like something that the judges can all then align on. It becomes an evaluation that the judge will be evaluated on. And it's not like if it passes all the evals, it's a perfect judge, but it just means it's aligned to me. And I haven't done a whole lot of that yet. When it says this development is currently empty, I'm not like I'm trying to build like the system for building the system, but I'm not actually building the system yet. Okay, claim. This is interesting. 6 out of 8. A candidate change can be copied, diffed, validated, and rejected without mutating canon. So yeah, so you can create these, like, it's got this concept of like a transactional candidate where it's a proposed change where it says like, what if, this character was actually male? Or like, what if this character died in chapter 5 or something like that? What does this say? Candidate. Before, Ada looks down at the algae's pale glow and says, maybe it likes the light. The candidate is Ada looks down at the algae's pale glow and says nothing. She has theories. She keeps them to herself. And so then the decision is like, is this a good decision or is this not? And then you can run the judges against it and see. So this is where, like, before, in my original prototype version, it was just me proposing things to Claude. Claude was trying things. I was telling Claude, like, review yourself, check for the internals. And this is like, you can see that it's becoming more of a structured thing for all of this. Revision remains proposed candidate until it's diff, validation, and before, after. So once it's already gone through the gauntlet and it's passed, then it can be included. So it's just like creating a structured way of doing this. 7 out of 8. A form is reached only when the same canon satisfies that form's declared constraints. So, for a novel, yeah, like there's different, this is what it's saying, that there's like these different criteria when it comes to different projections. So if it's going to be a novel, that's a different set of criteria that it might like fail on the number of scenes. Whereas if it's a feature-length movie, then it's going to be, you might like say that there's not enough content there to create a movie out of. Even though there are plenty of scenes, like it seems like the scenes are actually still too low too. But like it gets into more details about that, like saying, okay, but this isn't going to be a movie because there's not enough like in whatever XYZ scene. This is a series of a 60-minute series where each episode is 60 minutes. This is saying that like it can't be decomposed as well enough. Or this is a site. Oh, the other projection is into a website. I kind of thought about, we closed it, but I kind of thought about that, you know, how I demonstrated with the images and all of that. Like you could imagine that you could create like a custom site for each Storygraph. Like instead of projecting into a novel, you could project to like a rendered website, which would be kind of cool. And rendering, yeah, like rendering is cheap. Earning the claimed form is the gate. The small screenplay feature proves the tooling scene. This is such Claudeism. You can tell I used Claude to generate this back then. Funny. Okay, so what's this now? Claim. This is the final one. Keep the receipts. Every attempt should leave enough evidence to inspect what happened, including failure. So read-only manifest index. Like this is all the readable manifests that I have. This is like these 207, I think it's this here it's talking about. 12 of them fully completed. 179 failed in some way, form, or another, which might, oftentimes what that means is that like the judges looped 3, like I give a certain amount of time, like I'm generating a structured graph, and if it outputs like the wrong, if it outputs something that can't parse, then I retry an n number of times, and after n number of times, I just give up because it's either like hitting a length limit or it's just having problems. And that also goes for judging and all of these other parts. Like you can imagine that like if you've got a criteria and you're thinking about including it and you're going through the judges and all the judges keep failing, like you eventually just have to set it into a failed state. And so a lot of what this project is doing is like not only coming up with the judges and improving the suite of judges, but improving the reliability and the prompt to make sure that it does get a one-shot output that actually generates a valid output. So yeah, statuses are archived manifest values, not a live process monitor. So these are like the ones that I generated before. What is make intro browser? Oh, this is the quiet wood. What the judges said. Okay, so this is all the different judges. So this is a prose judge. These were the outputs. So this is like, again, you can see how it's like structured. What the prose judge outputs is like a JSON file. And the JSON file has these like major findings, minor findings, and then you can see like each one has this triplet because it's coming in as like a JSON block. They're coming in as JSON objects that have like these keys that I can key into and then create this website out of it. And also not create the website, but also take that structured stuff, parse it, and feed it back into the creative parts. So these are like examples of what the prose judges and some of these other judges. This is another prose judge. Lots of prose judgments on this one. 101 more. This is the graph for the quiet wood. This is it's a whole book. And then the final sentence, 2 sentences are, Amos removed his hand. Together they stood before what they had made. Names held in wood and no unwilling voice inside it. I have no idea what was happening in the story. Amos's thumb, wrapped in cloth, rested against the wood without pressing. Even if nobody pays for it, especially then. The answers settled between them. He did not bargain with it. Beyond the brambles, someone began to read the names aloud. The voice faltered at the blank spaces and went on. Nia watched and the people bend towards the silent boards, using the unheard note not as a failure, but as a place to stand. I don't know. It's not perfect, but like I do kind of feel like this is better than standard output from Claude. And this is from GPT 5.6 Luna. I'm using small models. I'm using small, fast, cheap models to do most of this. Okay, where are we at here? Pipeline. Completed, partial, and failed runs are inspectable evidence. Yep. Archive counts describe attempts, but not product quality. Yeah, so this is saying like, hey, just because 12 are completed in the archive doesn't mean there are 12 good ones. And then, yo, how you doing? But anyway, so then this is the end of the tour. So it just shows that like all this different part where we've got the pipeline, the entire I don't know what pipeline means, but then we've got the canon generation where it comes out with like this is the idea for the story, validating the graph, mass, which is like the story mass, the judgments. I don't know. I actually don't know what this tour. Oh, this tour is. I don't know what that is. Anyway, we can stop this. Yeah, I'm working on I'm talking about some of the projects I worked on. I'm not working on a project right now. I was working on some interesting stuff, but it was more like testing different models, testing Muse 1.2, testing the new Ox Alpha, testing the Qwen3.8 27B, and testing Gemini 3.7 Flash. And it was really interesting to see how they all compared and worked on a project. But yeah, so this is an explanation of like, this is one of the projects that I was working on this week. Was I was reviving this concept, or last week I should say, the end of last week, beginning of this week, was the super story graph. And like, I haven't worked on it for a couple days now because I've been working on other stuff. But this is an idea that like, I'm going to just keep pushing forward periodically, where it all comes from it. Again, like where I can't come from this is that like, I love open world games and I love the narratives in open world games, but they're just hard, they're too expensive. They're becoming fewer and farther between. And the thing that's being dropped about these games is the narrative stuff. So I just think that there's a possibility that as agents get better and as games become more cheaper to create, they're getting better and better at all the asset creation and all the world building and all of the visual fidelity and all of that other stuff. But this is my idea to like push on some of the story and the narrative crafting and what could be. And again, it's funny because like, even though all the 3 different projections that I was talking about, where you take that story graph and you project it into a novel, a feature, a series of 60-minute episodes and a website, like I forgot to add the actual thing, the motivating thing that caused me to like start vibe coding this, which was like the open world game. So that's something I got to make sure I add and continue to push forward. But yeah, so this is like, as I'm kind of explaining all the different stuff I've worked on, this is like a little fun project. Also, this is cool because I feel that a lot of the open source models and these cheap models that are coming out, like as I'm testing out Muse Spark, like I want something that's not just code, not something that's like making a website. I want something that's something like this, where it's like, okay, what about a pipeline for generating story graphs, judging those stories, coming up with counterfactuals, trying to integrate different parts of the graph, and then ending out at the very end with like a cool, good artifact. And if a model that's meant for coding can like be repurposed and used in this type of a pipeline, it's pretty cool. And so also you'll be like, I've been surprised at what models are good and bad about it. It seems like something that not every model lab is necessarily training for. So it's just kind of fun to have a project like this where it's working on something completely different from anything else I'm working on. Yeah, you're trying Ox Alpha? I was pretty impressed. It might be GLM. I talked at length earlier in the stream about like what might be Ox Alpha. And yeah, like GPT 5.6 Luna is amazing. That's what I was using for all of the super Storygraph stuff. You can see, like, if you click, oh crap, I stopped it from running. But like almost all of this was GPT-5.6 Luna. It's so good and so fast and so cheap. The one I don't really have any use for yet is Terra. Like Soul, it makes sense if I'm writing code, if I want the correctness, if I want the, you know, the large model, I want GPT-5.6 Soul. If I want the fast, cheap, instruction follower that just gets the work done, I like the Soul. But I don't get Terra. I don't really understand what that midpoint is for. I don't get it. But it's. I guess I'm not complaining that it's an option. I don't find a use for it. That's my sort of deal. But one thing. Okay, so I talked about Purr. I talked about Super Storygraph. I'm not going to talk about RLV loss yet because it's like a small thing. But I do kind of want to talk about soundboxing. So I'm not gonna do a lot. I'm not gonna say a lot about soundboxing. Soundboxing, just so you know, I don't know if anybody knows me or whatever. Soundboxing is a game that I created a decade ago, about a decade ago, and it was I talked about the story a little bit earlier about how I originally got into virtual reality because I wanted to create apps. I wanted to create like a Reddit app that would work in VR. And I really thought like VR it was this next medium for apps. But I ended up having to pivot to games, and the game that I created was Soundboxing, and it did pretty well. Like it funded my lifestyle for years, and I was an indie game developer working on this this Soundboxing game. But over time, like I got to the point where I got into a real rut with it as an indie developer, where you're kind of a solo developer, and when the VR industry was kind of like floundering, and I personally was like looking for, I guess, like technical challenges, and was trying to find ways of technically challenging myself and learning and all of that. And I got into this rut where I created like my own game engine basically for Soundboxing. And I basically like spent a year and a half building out this whole custom game engine in WASM, and I thought it was going to be this whole big thing where like the gamers would come in and like build different types of game. Like I was trying to turn Soundboxing into like a music game engine that all future like Beat Saber would be created in the Soundboxing engine and all of that. Wait, what was this? It acts 1-to-1 with GLM, but CAI just dropped a new model a week ago, which isn't multimodal. Yeah. You know what I said earlier, my dark horse is that I think it could be Longcat. I think it could be Longcat. I have no idea for sure. It's just like 30% chance. I think 60% chance it's probably just GLM 5.3V or GLM 5.3 Flash or something like that. But I think there's a small chance that it's, I don't know how to say this, Meituan, I don't know. But I think there's a small chance because they have really good agentic coding post-training. They know and they have the training ability. They know how and they have the compute to do the training runs that are needed for it. And they have like, I guess like enough, and look, it's a Chinese model company. So I think there's a non-zero chance that like they got an early checkpoint from GLM 5.3V or something like that. And they did their post-training on that. That's my like conspiracy. I think it's definitely a GLM base. It's definitely got to be a GLM base. But it's like, who did the post-training? Was it ZAI that did the post-training? Was it somebody else? Was it Cursor? I don't think so. But yeah. Tencent, maybe. But yeah, so Soundboxing, I got into this rut where I created this whole game engine. And by the time I got to the end point, I got it working. It's like you can go on to, you can go on to Steam and you can like get to the beta. Oh, by the way, I'm glad that it's still very positive and like people aren't leaving terrible reviews. I don't know if it shows the beta, whatever, but there's a beta that you can go onto Steam and but is Longcat big enough to offer? I don't know. I don't know. That is the crazy part. Okay, what I will say though is that even though they say that they can do, wait, where was it? Even though they say they can do 100 trillion tokens a day, and then news research said, I don't even know if this is a joke or not. I don't know if it's a joke or not. I think it's a joke. But like in my experience, when I'm actually trying to inference through them, they can't seem to support, like maybe they have like the legal runway to do that many tokens, but they don't seem to have the inference speed to in 1 week generate that many tokens, if that makes sense. I keep running into like, it seems really tough to get it to complete like an agentic turn. I had to keep pushing it, and it kept running into, especially if I did a loop where it would like generate an image, read the image, and then try and modify the code based on the image that it read. After it got to like 4 images, it like cannot complete. It can't, it's like the tokenizer, I don't know if it's some weird thing about the tokenizer or how the image patches are being sent into the LLM or what, or and also I had ones where it wasn't even using images, where it just got to a certain point where it didn't seem to be able to get past that. It kept 503ing or 504ing or running into weird errors. So I think like great that you have the idea to generate 100 trillion tokens in a week, but I don't know if they have the throughput to do it. That's good. I'm glad you got a lot done. I have had pretty good success with it. But I will say that when I put it in a heads up comparison between some of those other models, it didn't do as well as I thought it might. I would say my vibe experience with it is better than my like structured testing experience with it, if that makes sense. Like it feels better, but it didn't produce all that great of stuff in the end. I don't know. It's interesting. I'm really excited about it though. I just hope that it's true what they say is that it can run on consumer hardware and it's going to be open source. That would be incredible. I would love that. I'm glad you're having good luck with it though. Yeah, but so where was I? With soundboxing, let me close some of these extra crap. Yeah, so where was I? What was I even thinking? I don't know if I want to talk all about soundboxing, but I'll just give I'll give a high level thing. I can go more into it in detail next week, I think. Yeah, they've been saying consumer hardware. Somebody said 2 DGX Sparks. So that's like what? That's like, it's got to be like a 200 million parameter model or something like that, or 200 billion. I mean, I don't know. But yeah, so soundboxing. So okay, I got into this rut where I created an entirely new game engine for it in WASM. It was crazy. It was honestly the amount of work I put into it and the amount of like, it was cool. It was a whole, and you can select it if you go into like Steam and select the like the V2. I think it's like V2 beta or something like that. You can try like the new engine that I created back in 2019 or whatever. But I ran out of money. Nobody was buying it by that point. I ran out of money, and I was also so burned out by the time I got to the end, and I realized that like no one was going to build a game in my engine. My engine didn't even have an editor. Like it was a pure code-based engine, and it was really cool, but it wasn't that good or useful. And I needed money, so I ended up having to take a job, and soundboxing just became this thing that kind of went on the back burner. And as VR has faded, it really just became something that like I support and I continue to keep it updated. But what happened was last week when I had this or 2 weeks ago when I had that catastrophic server outage, and I had to port from I had to like restore from a backup of soundboxing. Thankfully I had put in like a periodic database backup that I had never tried or not for a long time. So I was very, 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 very lucky that when I had that catastrophic failure, I was able to restore from like actually a 1 day old backup. And since there's not many people using the service anymore, that 1 day old backup was pretty good. But I had a lot of people reaching out to me from the community saying like, hey, what's up with the game? Why isn't it working? So and they were like telling, because I jumped back in the Discord to answer those people and talk to those people, it became something where I was updating them saying like, oh, I'm working on the backup, I'm working on the restore. I didn't know anyone was still playing it really. Like, it was kind of cool to see. And then while I was in there, they were like, hey, can you check out some of these challenges that aren't quite working properly? And like, could you check this out, that out? And it got me started to thinking about the game a little bit. And I realized if you look at it says September 29th, 2016, and we're in August of 2026. So we're coming up on the 10-year anniversary of when I launched this thing. And at the same time, I was realizing that like with agents, I can just forget about the whole new engine. I can forget about the old game. And also the other thing is like this game, it's built in an old Unity version that I don't even have access to anymore. Like they don't sell you the version of Unity that I need to continue working on this. So like if I was to update this, I would need to either find a way to get the old version and either upconvert it to like a newer version or start from my crazy engine and start there and like try and get it out the door. But I was realizing that like with agents, I don't need to do any of that. I can just point the agent at the old version of the software and say, let's rebuild this today with modern technology. And like I can use an agent to basically bring this up to speed and create like a 10-year anniversary edition of Soundboxing. So that's something that I started working on actually. Like that's what I was talking about the Storygraph thing where I was working on that project, but this has started to become my little fun side project, which is like, let's work on a 10-year anniversary of Soundboxing. And what can we do? Well, how far can we get? What can we build? And I'm not ready to share too much yet, but I will say that like, okay, I'll talk a little bit about what my process, which is the way I did it was, here, let's get rid of some of these. So the way I did it was, how come I can't see it? So I'll just do file open directory. Oh my gosh, all my branches, my work trees. So first I created, before I did anything, do I care about this? I basically found the known good version that's running. I found the source code, and like it's so weird. It's so frustrating. It's like it's such a mess because, like I say, I worked on Soundboxing 2.0 back in the day. This 2.0 version, and that means that there's like 200 commits on the main branch of Soundboxing beyond the released version. The released version that like people play right now. When people download Soundboxing and they play it, it's like 200 something commits behind. So I had to go find like the version that's actually released. And then I had to create like a prompt that said, don't try to go forward beyond this. Stay at this, like I created a tag. And I said, stay at this tag. And then I had to also do the same thing for all the different components of the game because there's so much development that I just want to like forget about. I got too pie in the sky, too crazy. I created this whole WASM game engine thing. Okay, first, before I did anything, I needed to like, I used Fable and I used Claude Code. And I used a workflow. Actually, let's see if I can. It's interesting that these work. I thought there was just one workflow. Oh, here we go. Subsystem doc. So I saved out the workflow that I had created. Let's see. Can I like? Let us sound. I'm going to say create a single file website that visually demonstrates in a nice way this workflow so that I can demonstrate it and share it and make it easy for people to understand. Once you create this single file website and single file page, start a server that serves it and then open it in the web browser. So I created this workflow that it's going to help me show later, but it's this Fable workflow where I said, okay, I checked out the directories and I found the right tags for like what the released version was. And I said, we're just going to do a full and complete like Bible description of what the Unity game looks like, what the website looks like, what does the API contain, and how does it work? Basically, like give enough detail so that that if this set of documents were given to a new team without access to the source code, that they could successfully create a Soundboxing 10-year anniversary edition without looking at the source code. And so I wanted to like basically just have it really, really explore every part of the code base and create basically like a Bible of Soundboxing. And the way that it worked was like, if you'll see when I sort of load this doc thing up, if it creates one. But the way that it worked was like it would pick an area, it would generate first like the first version of it, and then it used an adversarial review to find flaws in that, and then it took the adversarial review, sent it back, and improved the documentation, and then only after a couple of rounds of that would it like sort of save it out and say it's finished. And it using Fable for most of this meant that it like actually got really quite good, and it did quite a good job of extracting all the information that was necessary into a series of 5 or so markdown documents. And like I spent a lot of time and a lot of my Fable credits to do this, because I think that like having it in a written form, having it like distilling as much knowledge as possible into like a prose type of a form, I thought was just really important. And so like what that resulted in is like an API doc where it's a full. This is a almost 10,000 line document that describes the full API and exactly how that API works and all of its quirks and the good parts and the bad parts and all that other stuff. Also, the Unity game. The Unity game got a 10,000 line document that describes every single part, including like there's mermaid diagram. Here, let's see. Can I render it quick? It literally has things like, the specific locations in the 3D grid where the reflection probes are located, so that the reflection, like directional light and a specific angle in Unity's 3D space, and like all of this stuff, it gave enough information that all of that. I want to find the mermaid diagrams if it's got one. Come on. Oh wait, I think I can go to GitHub. You get the agent style usage spike. Oh, okay, that's not so good. Come on now. But yeah, so okay, mermaid diagram. It's got these like nice diagrams. I mean, like this is a huge volume. I mean, by the way, seeing this output, it just made me realize how much work I put in, because this is everything before the. Okay, also I didn't finish. API, 10,000 lines. Unity game, 10,000 lines. Website, 6,700 lines. Web VR game. I actually have a whole web VR game that I had a lot of help with. There were some people working on a startup that helped me out with it, but a lot of it was me too. and there's 11,000 lines of code of documentation about that. So when I was reading all this, it was just making me really realize how much work this was, because that was all before I even did the bulk of all the stuff that I did, which was that huge engine rewrite. And yeah, I don't know. So reading through all of this and like reading through some of this stuff, it made me really realize like, holy crap, I did a lot, and it was a lot of work, and gaming is hard. Being an indie game developer is just freaking hard. So anyway, that was something that I thought was pretty interesting. But yeah, how are we doing on this visualization? It's not that important. I just wanted to get a little visual to like demonstrate what this workflow was for generating these 10,000 line documents. Because a big part of this is just like, I can't be telling an agent to go look at the original source code all the time. I wanted like a set of documents that it could go back to, and then if it needed to, it could. I call the original code base the vault. If you need to go back to the vault, you can go back to the vault. But for the most part, it should just be able to just go to the docs. And so that's happening. Looks like we're about to share. Oh, this is kind of cool. From legacy code to trusted blueprint. 4 systems, 1 shared truth. Each codebase is split along concrete boundaries called seams. A seam is narrow enough for one agent to hold in its head, but complete enough to answer a real rebuild question. So these were the 4 that I was talking about. Okay, this was the workflow. One specialist reads the real source for each seam. And so it would do research. And then there was another worker that would adversarially verify each claim that was made in this research. Then, like I said, it gets sent back to a reviser. So I don't remember if it was the original research agent or a reviser agent, separate one. But the idea was that like all the things that the verifier found to be incorrect or half-truths or whatever, insufficiently specified, that would all be sent to the reviser to fix. Then it would be sent to an outliner to turn all the research into 4 to 7 sections. And then it basically like took all those different areas of research and all those different things and turned it into one draft. So there was the scatter part. This is all kind of like scattered. There's a bunch of them doing this, a bunch of them doing this, a bunch of them doing this. And this is sort of like the gather part right here, where it's reducing down into one document. The concept of one document. And then it splits that out again to say, okay, now that we've got our outline for what we want our document to be, let's fan it back out to each one of those things to fill in their sections. And then we merge it here, where we're saying, okay, now we've got our outline, we've had each individual one fill out its section. Now let's merge it together and make sure that it's all good. Then we had a full document critique part, and then basically revision to make the final one done. And this was done 4 different times for those 4 different documents. This is a really cool website, by the way. Codex is getting better and better. This is pretty cool. Okay, diverge, converge, and harden. Yep, diverge, converge, and harden. No single agent gets the last word, although I guess maybe the finalized one. Portable by design. The final documents explain behavior instead of preserving an old engine by accident. They are written for one product that must reach web. Oh yeah, and I was kind of just saying like, don't assume that this is going to be built in Unity again. Like build it so that it could go to web, desktop VR, standalone headsets. There's all these there's Vision Pro now. But yeah, like it did take a lot of calls. It took a lot of calls. This like took my whole Fable budget for a week. So in the end, I got these 4 Bible documents and provenance. Which code is, this is where I was saying before, I'm like, Don't try and go forward. Stick to this brand, stick to this tag. The Unity trap. It's not a release branch that diverged. It is an ancestor of Origin. And by the way, this is old enough that it wasn't main. If you open the repo and reason only from Git, you will conclude that it's the main product. Master is the main product. It is not. And so this is like, I had to keep telling it, like, don't assume, like, stick to this tag. Anyway. But yeah, so that was the start of my process, was creating these documents that like fully describe the existing Soundboxing game. And then the next thing I wanted to do was feed those documents in and start working on like prototypes for things. But unfortunately, this gauntlet, this process, one of the things that it did was document all of the security problems with the existing code base. There are things here and there. Please don't look too hard right now. I'm working on it. But because it wrote down the security stuff that it saw, anytime I would point a Claude-based agent at those documents, it was like demoting me to Opus 4.8, not even Opus 5. It was demoting me to Opus 4.8. And so I had to use codecs to create a safe subset of the API, the Unity game. So the API, the safe subset is 7,000 lines of API. It's 10,000 for the Unity game. Unity game must not have as much. API had a little bit more. Less and less. I'm working on it. The website is a half the size, basically. And the WebVR game, or no, this was 6,000 or something. And the WebVR game, which was 11,000, is still 11,000. Because the WebVR game doesn't really have any problem, like any types of security problems. But so anyway, I created this safe subset, which ended up using codecs to just filter out all of the egregious security stuff. And then this now is the thing that I have been using. This like safe subdirectory is the thing that I mainly use for everything. So I'm pointing most of my stuff at it. I'm pointing not just Claude at it, but codecs and my open agents and all the agents that I have working on this project. I have them kind of like pointed here. And then I workshopped and I started creating like, I don't know if I want to give away too much. I just want to say that like that's the, well, let's just stop here. So, I'll give a little preview. Let's see if I can give a preview. What I will do is, so the new engine that I'm building to rebuild Soundboxing. So this is like, it's been really fun for me because I just want to say that like, so Soundboxing was in the beginning it was a lot of fun and it was successful. So anytime something is successful, it's fun. And it was like a big part of my life. But I did get into a rut with it. And I got into this like it was hard for me to think about the game. In fact, like, there was one time when I was thinking about like a particularly tough problem I felt. There was one time I was stuck for months on a technical thing around the new game engine. And it just like took me so long to figure it out. And a couple years, like 5 years later, I was mentioning something about that problem and I started crying. Like I found myself crying thinking about it just because it was so stressful and such a problem. Like I ended up solving that problem and got it working. But like, there was a period of time when I felt so alone and so myself against the world, and I couldn't figure out how to do stuff, and nobody would help, and the industry seemed like it was dying, and I was running out of money, and it was like a hard time at parts. So then, I guess like that moment where I found myself kind of like emotional over thinking about a technical hurdle that I overcame. It reminded me that like there's still just a lot of emotions wrapped up in this game. Now it's like probably 5 years later after that, and I don't have as much. I don't have as much like emotional sort of feelings about the game anymore, except for some of the good stuff from the beginning. Except that like now there's all these agents, and like the agents are kind of giving me this second life to this. It's giving me this like kind of revival of I can do this. It's not going to be even hard this time, you know. Like this is fun now, and it's a side project, and there's no pressure on it, and it's a 10-year anniversary, and if I get anything out at all, it'll be fun. And like it's just been this really fun project for me to revisit soundboxing, and so that's where my tokens have been going this week. Is this like Soundboxing 10-year anniversary project. And so I don't want to give the whole thing away. I do kind of want to share like a quick little WebVR in progress build though. Okay. Let's switch to, I'll use Qwen and I'll say, please get this running locally. So I'm not going to talk about all the other stuff, but I am going to give a quick like teaser of some of the stuff that I've been working on, and it's turning out really fun and great. And this has been like very little work. It's been like a week of work, and it's all started because like people are still playing it, and they were pinging me, and they were asking me to fix these things, and like now it's possible. So if you watch my streams, you know that there's going to be a 10-year anniversary potentially. I'm not promising, but like if I can get it done in the next month, basically. So what did I say? It was September 29th. It's August 22nd. I have basically 1 month and a week to see if I can get something working. And here we go. So here's like, I've got a version. This is in the browser. This is like a WebVR version. And I've been porting over, like, I've been trying to port the environments over a little bit, but like I can't use the original assets for that particular thing. So I've been putting various agents in loops saying like, try and build something like a lava planet, try and build something like a sky planet or a depth planet or a high planet. And then like, oh, interesting that Omxos has a world now. That's not supposed to have a mesh, but like all of these are kind of like these different you know, like skyboxes that I used to have. Oh, wow. Some of them actually have geometry. I got to get rid of that geometry. That's a bug, actually. But let's go to lava. I don't like the lava planet right now. And then I was able to load in all the original old score, or the old beat maps. So there's like 30,000 beat maps that are going to work in this game. And so, first of all, this is like a demo. This is a demo that doesn't have any music. So there's no rights issues or anything like that. I can just show it here. But here, I'll just do a real quick thing. This is an in-browser version. It's like, actually, this does run in VR already. It runs in XR, WebXR. But you can see I'm like recreating some of the reactions that we used to have. This now, the old WebVR version of this game didn't have any of this cool stuff. So it's been really cool to see like this is like a WebXR version that is turning out pretty fun. And like even just with my mouse, like I was thinking about with my mouse, or with like I could use like a thumb. If I did like a touch version of this, you could use your thumbs to tap. It might be fun. But so whatever. So there's that. And then like I said, all the old games come in. Like I need to somehow find a way to mute this, so I won't play this. I'll mute this. But you can see, first of all, the replays came in too. Like you see where the original replays, that's all in there. But then, so this is a challenge that a user created in the game, and I'm able to load it into my new system that I created. This is a WebVR based thing, but it's loading like, and also I created a much more efficient format for all of this stuff. Like there's terabytes of replays and challenges in my old system that are it's costing me actually a lot. And I found a way to like massively reduce the size of all this stuff so that I can store it for a lot longer and not have to really think about it or worry about it as much. And you kind of create more backups, and it just makes it all better. But what's really cool, I'm gonna and by the way, look, it's got the YouTube integrated already. It's working. It's pretty fun. It's kind of neat. But what I will do here, what really has me excited is, so YouTube was always like the Achilles heel of this thing. Like, if I was always worried about the YouTube aspect, and it was also always the hardest part was getting YouTube integration working, making sure it's synced up. It never did. It never does. It, like, actively, the browsers won't give you access to accurate enough information to really sync it up properly. So I had to create all these in-game mechanisms where you could kind of like move yourself and align yourself to what and I just had to do so much stuff. And I was always worried that like there's potential that they wouldn't like what I was doing and they could find ways to make it hard for me or shut me down. Even though this is just an iframe, it's just a web browser, like I'm putting in all the normal ads, like you're seeing all the normal ads. It was always the way that the game worked. But it was just always this thing that made me nervous. But what's happened also in the intervening time is something else, which is generative AI. So that there's a theoretical possibility, and I'm going to show you something. Oh, crap. Yeah, I'm going to show you something now where these two songs I generated locally on my local machine. I generated the song. This is an asset that like so I could make part of the game that the start of the challenge is you generating the song that you're going to play against, so that there's no reliance on any third parties and there's no rights issues and no content issues. That part of the act of creating the challenge, like it's actually kind of this new thing where like creating the challenge is creating the song. The whole thing is your inventive creation yourself. And so this is just an experiment where I downloaded an off-the-shelf MIT licensed music generation model called Ace Step. And I'll show you just two examples of it real quick. Not great, but like there's some I can like create a challenge to this. It's fun enough. And it generated a beat map. This is like an automatically generated beat map, also using like a generative beat map thing. And here's like a hip hop one.
Pressure on my shoulders, I don't fold. I
don't know. I was looking at this and I was thinking, oh my god, it's easy to revive. It's like I can have there's a path to sovereignty and not relying on a commercial entity for any of the music aspects of it, to getting that YouTube player out of there eventually, theoretically. And then I started thinking that, holy crap, I actually can like. There's one thing would be to like generate the song all up front and then create the challenge to it. And that's fun. But imagine if like I can take the data that I have for all the movements that people have done and the like descriptions of the songs that they were creating. And I could create a new type of an instrument where you start with a prompt and then you start boxing and the music is created based on your actions. Like it's generating the music 200 milliseconds ahead of you based on what you're doing. So if you start to get really excited, it's creating like based on your prompt, and you start to get excited, it amps up the energy levels. Or if you start to like go to a relaxed phase or a second, it fades out and goes to something else. Like I'm realizing that soundboxing could be an instrument, actually, its own instrument. So anyway, like that's all pie in the sky. Like first things first is getting the old existing challenges, 30,000 challenges that have existed for ages, and making sure that they don't play audio, but making sure that all works. And by the way, like that it works super solidly well. And if you skip forward, if you skip backward, you know, it does the right thing. Wait, what's going on there? Skipping backwards, not something I tried yet. So, and then there's like all kinds of things I'm trying. This is all the different configurations I can do. Let's reset them all. Yeah, so I'm not gonna do too much more than that. I think I could talk a lot more about it, but I'm not going to because I don't want to give it all away. And obviously, you could tell that's still work in progress. Like, it still has a long way to go before it even matches the 2016 level, although it's getting there. But yeah, so this idea of first creating like a document-based Bible of the old code, then building a new game based on the Bible, and then beyond, and then going beyond and taking it to the next level and saying, what if we create new types of instruments where just by doing beatboxing, you're inventing music that's also going to be used for the creation of the song? Like, I think that there's so much cool opportunity here, and it's so low. It's like so low touch for me to do it. It's easy for me. I can just kind of hit, you know, I can give it a goal mode and kind of leave it for a day, come back to it, give it my judgments, give it my feedback, kind of go back, try it again, give it like visual fidelity goals, give it performance goals, make sure that it's like, it's, and then by the way, it's doing stuff that I never could do with my own game development skills. It's doing all kinds of stuff in the shader that I would have done as meshes or as other things. But because it's being done in the shader, it's like super portable across all these different platforms. And so, yeah, it's been, this is like one of these things where it's like, this would never have happened without agents. Without agents, soundboxing is kind of just going to fade into the distance. But with agents, I can potentially revive the game. And I don't know, like what I'm thinking is that I will launch it first as like as in a preview mode. I'll launch it to like as just a WebVR game, because if you go to soundboxing.co, there's kind of like a built-in WebVR game that, like, let's just replace this first of all. Like you can see, this is the WebVR version as it exists today. We can be so much better. We can do so much better than this. So this is the WebVR version as it exists today. Like this could be just wholesale swapped out for the new version, for the new thing. And then it would be cool if I could launch this and deploy it to all the people who have the soundboxing game, because, you know, they deserve a game that stays up to date and gets better over time. And now that we have agents, I can kind of like, as a side project, commit to doing that. So that's the hope. I've been having so much fun with this. It's gone from, soundboxing has gone from something that I kind of didn't want to think about because it ended in this like weird rut, to this new thing that I'm having a lot of fun with, revisiting, thinking about again. And like, it's not a big thing. It doesn't have to be a big thing. It can just be a fun thing for me to do, a little side project that also helps me keep, like, also this is pushing all the limits of all the agents things. Like the agents have to do these loops where they generate, like I have it doing this whole thing where it generates a loop of trying a change, running a playback. It like finds an old playback from somebody that played, like a score. It replays that playback so that there's something going on and there's action going on and there's realistic reactions and things. And then over in the middle at specified points in the replay, it does like screenshots looking at all the different directions. And then it can take those screenshots and then analyze them. And like, it's doing some of the most amazing, actually, let's see if I can find real quick. Like, I'm not going to show a lot of it, but Qwen3.8. Cache analysis. Oh shoot! I wish I could find. You can see all the iterations it's doing. There was one where it was like, if I can find it. Yeah, I was analyzing like, so when you punch and it gives an explosion, and the explosion happens, it uses these like particles, and I was kind of like, oh, the particles could be a little. They don't match what they looked like in the original. I'd like them to be better, closer to the original. And it like did this whole analysis where this isn't even the one that I was thinking about, where it was trying these different versions of it and then doing this like deep, like this is actually kind of close to what I was thinking about, but this like deep analysis to figure out what the right approach was. Let's see. Yeah, it does these like analyses. It started doing a thing where it grayscaled it so it wasn't being fooled by color stuff. It was like looking at blocking. Crest. It was the crest ones, I think. Maybe not. Maybe it was. You can see it. I have ways for it to test the XR stuff too. Testing Apple Vision Pro versions. Oh yeah, this is. You can see it does have like the characters that. Oh, first maybe it's this. Oh well, I think I'm not going to be able to find the really cool analysis it was doing. Where I was, yeah, you could see like it did this burst where it wasn't quite like it was these like dots that I wasn't crazy about. But like that's it. Like this is so fun. I can just give the high level feedback. It does. There's versions. It like it has a GL version and also a web GPU. Oh well. Bokeh. Yeah, this is what I was looking for. This is what it was doing when I was telling it to like match closer to the original. It was trying to find out what it was doing wrong, what it was doing right. Look at this. Like it. I didn't ask. This was for it. This was for itself. And it was trying different versions of it. It created a table like these loops where it's analyzing itself and improving it is just so cool. It's a new world. It's a new world. I'm excited. This is fun. Soundboxing can come back and not be like a big thing. And I'm learning about like sort of like modern game development and XR. There's XR stuff that is new in the WebXR spec that I didn't know about. There's all these kinds of shader tricks that I've noticed it using that I never knew about. Like, it's all just fun. This is fun. I'm having a good time. So, no promises, but I'm pretty sure I'm going to get a Soundboxing 10-year anniversary edition out in 2026. It's fun. So yeah, I don't want to give too much. I gave a lot away. I talked a lot about this. I said I wasn't going to give too much away, and then I gave a lot away because it's fun. I'm having a good time. I don't want to like moderate that. But I'm not going to go into the details about like the other, like because I could go into the details about the song generation or go into details about Qwen, the new engine. There's like a whole deep dive we could do on that at some point, and I will. Let's do it at some point. But also, it's going to be interesting to see how this translates to, like, I'm developing it in a way that theoretically could be ported to desktop, could be ported to any of the mobile platforms. So, like, there might be ways that we can get it on, like, Quest or on, like, Android XR, or get it onto the Apple Vision Pro potentially. So all of that stuff is in the air. It's all possible now with agents. I don't know. So yeah, super exciting, super fun. I'm happy about it. But yeah, I don't want to give any promises because I don't want to get burned out on it. I don't want to do anything. And my other stuff might come up. But Soundboxing has been a fun revisit for me. And that's probably where I'll end the stream. It's been over 6 hours. It's been a good time. This was good. This was fun. Let's see. Did I get everything? Oh, the one thing I didn't talk about. So I said that I used this ACE step for those two songs. I was looking also at Minimax Music 3. That came out just days ago. And it seems to be a much better music generation model. But it's not very open source. And it also has no encoder, which makes things harder. It's also a little bigger. It's like a bigger model. This one, A-Step, it seems to be the one that I'm going to play around with first because it's MIT licensed. It's like a really permissive license. This one makes you put a watermark on stuff if you use it. So I would either need to like, I was thinking like if I take it as like a base model and then do sufficient training on it to the point where it's basically a new model at that point, then I can probably say it's a transformative art, it's transformative work. But I don't even want to think about that stuff. This one's pretty good. I've got a bunch of like I've started to prepare data in it's really tough because I don't have access to like all those songs that people are playing I can't just like go to YouTube and download the music and say like train on that. It's not the way it works. It's not the way it mechanically works. It's not the way the rights work. It's not the way any of that works. But I can do analysis on those songs and generate textual descriptions about what they are. And then I do have access to all of the motion data and then the score and then like the actual challenges. So based on all of those things between the textual descriptions, the existing model of A-Step, the motion data and the challenge and score data, I can create a really cool. This is where this new model that I'm going to generate is like an instrument that's never been created before, and it's only possible to be created because I created this game 10 years ago and collected data ever since then of motion aligned to music. Nobody else has that I know of. And so I don't know. It's just like all of this stuff is so fun and cool, and I don't have to spend any time on it. I just press enter, and I come back next day and see what it did, and it's just like it's so much further along than the last time. And yeah, so this is fun. This is fun. But okay, so that's pretty much it. This was okay. How do we feel about today compared to before? This was much better. Last week, I did one project throughout the whole day, and that was like one big project and one big thing. This time, we talked about a lot of different stuff, and I think that was better. I think this is the way to do it because this is gonna, first of all, it helped me keep the forward motion of the stream, but then also like I think it's gonna be easier to cut up into little videos. I think it's gonna be easier to cut into stuff to put on YouTube, and I think like overall, it's more fun. So I was wrong last week. This is what it's all about. It's all a learning experience, and yeah, I think I've learned a lot already, and we're getting better at it as we go. It was also fun. We had like multiple commenters. We had multiple people coming in and talking about stuff, and so yeah, it's cool to have like people join in and people saying stuff and participating. And Kevin, my brother, joined up for a minute, so that was cool. It was cool to say hi to Kevin. He had some feedback, and it was cool. This is cool. This is fun. I'm having a good time with all this stuff. I'm loving agents. I'm loving streaming. I'm loving all. This is fun. Till next time.